Hello, everybody. Welcome to Off the Record, episode 5, season 2. Hi. Hope everyone is doing well. We've already got Trey and Tabs. Oh, hi, Tabs. Chadwick, Havard, Pete, Sean, Donna, Tobias. Hi, everybody. I'm glad you're here. It should be an exciting one. Well, I hope so. We're going to be playing with scales a bunch. That's the plan, anyway. Um, Let me think. I didn't know what the episode was going to be. And then starting yesterday during the stream, I was like, oh, maybe we should spend some time in XP dynamics. But then we ended up getting the scale stuff working so well. So I really want to continue with that. So maybe next week we can tackle some X particles based dynamics. I think that'd be a good thing to learn. Some more, it's just not something I'm super familiar with. So it might be quickly checking out a couple little clips of their example videos and then trying to figure the things out. I've tinkered a little bit, but clearly you can get a little bit more advanced on there than I've been getting. So that would be very nice. Sam, Dean, Zach, Rob. Hi, Rob. Rob is one of the new people who I think started supporting yesterday because the scales were going so well. He wanted to see more today. ATI, hello. So, Dean, Dean and Rob both joined in, and you're both the ones who replied for getting into the Patreon Slack quickly. So I super appreciate it. Thanks, everybody. Everybody who's in the stream is almost everybody is pretty much a Patreon supporter, and there's a couple of people who just have supported in other ways as well. So so far the hat has been a visual cue for the streams, but more it turns into in the winter because I'm constantly putting a hat on and off that if I comb my hair, it just gets super messed up. So if you put the hat on, so instead I just wear the hat, but you can see the hair is all super crazy underneath as well. So that's another reason for the hat. It's fun work. It's all super poofy, but that's just a good reason to have the hat. And you have a little hair poking out there, so that's fun. Chicago weather. That was yesterday. I saw some people in the chat were like, "Oh, it's really bad in Chicago," and I was kind of like not kind of processing it because we were doing other things, and then I looked out the window and it was like blizzard and I couldn't see more than a couple buildings away. I was like, oh man, I gotta go to a meetup. But then by the time I left the meetup downtown anyway, the snow had stopped and everything had already melted again. So it's still snowing around here, but it's not too bad. But it's really cold. What camera do I use? I am using a Sony A6000. And I bought a special cable and it converts to a little external Magewell like external video card. So essentially it's taking the viewport of my proper like point and shoot camera, and it's converting the viewport into the webcam. So that's the setup I have for that. It just gets input like a webcam, but it looks way better, and I can get some depth of field going, which is very nice. Let's see. K Lopez. I'm not sure if it's Clopas or K Lopez, but yeah, thank you. I like making videos, so they're super fun. I appreciate it. Given inside. Gives inside C4D also the same particle system like P-Flow or TIE-Flow like in 3D Max? I'm not sure. That's not a full question, so I'm not sure what you mean. I mean, yeah, Cinema 4D has thinking particles, but it's based on the thinking particle system that was being developed, but it was integrated into Cinema 4D in version 8, and they never updated it, but the company that makes thinking particles kept on making it, and they got more and more advanced. So that's like everybody else's X particles is their thinking particles. So ours is way behind. Adrian, welcome. Look at the people showing up today. There's most people we've had in the bonus stream because we're going to be talking about cool scales. But let's just cover a couple last questions here before we start trying to learn new things. What is the average salary for a Cinema 4D artist in the USA per month? I don't feel like I have any insights into that because I'm not really in the world of freelance. I'm also in Chicago, which would bias the prices to probably be a little bit higher because it's a bigger city, although it's nowhere near as expensive as New York or LA or San Francisco. So yeah, Sean's saying a giant range of anywhere between 40K and 150K, and depending where you are in your career, what software the kind of studios you can get a job at. So yeah, That sounds like a fair spectrum. Um, let's see. Low design. Can we add different materials to a volume object? The only way I can think to do that easily would be using like proximals as some sort of mask. But today we're going to be working on scales on an object. Who else we got in today? We got Bobby M. Adrian, and of course, Low Design showing up. So excellent. But in any case, we got a lot to try and cover today. Anyone who maybe wasn't here yesterday, let me show you a quick recap of where we end up. I think I've got the file. Let me share the screen. Oh, looks like I closed everything. So pop open here. This is where we ended yesterday. Is we were trying to make scales, make nice looking scales, and make geometry based scales. And that is where we ended here. These are full geometry scales, and we got them to follow the curvature of the object by making them fully dynamic and then using field forces to make them blow over in the correct direction. And we're even using the simplest connector, which is just the just a hinge connector type, as a way of doing them dynamically. So some of the what I'd like to do is try and clean up the process a little bit. There's several things I want to do. We should try to do a couple different meshes. Let me cover this. Things I'd like to explore. Cover some different meshes. Try and get the entire workflow in a single scene file, and then see what happens. See how far we can push things if we were animating a character. Like so there's, and if we're going to animate the character, and I'm not going to go crazy, we're not going to like animate a full character, but we'll make a little bit better of a structure. If we can get the scale of the scales working better, and if we were to animate a character, can we get the scales to stick? And I can think of two different methods for that. One would be keeping them dynamically stuck on the object, which might not work, like keeping them dynamically stuck. If we deform a mesh, I don't know if a connector stays connected. So that'd be one thing. And then the other would be to bake, because it's going to take forever to simulate. In fact, we might be able to create more clones, but I could imagine doing a version of this where these are single polygons and we run the dynamics on the single polygon, and it's going to run a lot quicker, and then running the clones on that, or even doing like a sub poly displacement after the fact. But then I think part of the advantage here is they don't intersect, because what you see is what you get, and then smoothing out would just be pretty minimal at the end. And then the other would be to actually bake it down and turn into a single mesh, which will run really quick, and then we can just use a mesh deformer to have it just follow the body. And at that point, they would be deforming in not realistic ways, but for the most part, I don't think you'd even be able to tell. I wonder if there'd even be a way of, actually, I don't see any reason why we couldn't do the same trick that me and that the same trick that was done for the very first rocket lasso tutorial, which would be to create a surface and reflect it, and then we might be able to reproject that back on as a texture instead of a mesh. So there's a lot of different avenues to try and make this useful. We won't necessarily pursue all of them today. Oh, and I completely forgot another thing I super wanted to try and focus on was actually getting the target effector to work, because if we did the target effector, we might be able to skip several steps here. We might be able to skip the entire step of using hair if we can get the orientation working correctly. So that's actually a super duper important one. So that is the current idea. So it's warming up quick. I'm going to open the window. Super cold outside, so it's only a little bit open. Zach, thanks for making it. And we are ready to start. Monsieur, hello, welcome. Thanks for making it. I'm glad we've got all these extra people. All right, so into cinema. And let's see, where should we start? I want to do, I guess, making some very... Let's make a mesh, something a little bit more practical. I'm trying to imagine what's something, I mean, it doesn't have to be like realistic. I'm just trying to think of something that we can make scales. That's not going to be too crazy. I don't want to push the limit. I don't want to push the limits to like absurd degrees. If we're making an entire character, like the way that the stuff would travel along the face and everything there could start getting pretty complicated. I don't want to worry about it on that deep of a level, but I'm kind of almost picturing like a pretty cartoony looking character that's almost like a Christmas tree shape. And then putting arms on it. So let's tinker a little bit. So MF, I'm going to do, what is it, UB to do a ring selection, MF to do an edge cut. And I can create a couple edge cuts. I want those to be somewhat visually even. And then select polygons, grab that. That, I for inner extrude. Yeah, see, I kind of intentionally want to make some of the shapes here a little unintuitive, like so we can mess the scale up, because I want to see how well we can get around that. Make that a little bit more rectangular. And then D. Now, I was kind of thinking we could aim for something that's a little bit noodly arm. So I'll scale the X to 0, flatten that, scale the X to 0. And now with these two selected, pull those down. There, and now those are flat, so I'm gonna hit D. And like these could extrude out. Now, if we were doing something that was a little bit noodling arm, then these would start curving downward. We could do that, but I'm not even sure if I like this shape. If it was something going over. I think because it was originally Jess's question that I was almost picturing one of her characters, so that's probably kind of a bad idea to go that way. Why don't we just try and make like a generic dragon shape? I don't think that would be too hard. I mean, it's not like going to be something crazy detailed, but if we were just making some basic shapes here, we're going to keep it so simple. I'm going to hit the letter D for extrude. This is a cube that is 200 big, so we're going to extrude by 200 and just say apply. Okay, so that's the overall shape of the dragon. We're kind of making a Chinese dragon shape. So if we were making, let's see, let's do some symmetry, edge mode, MF. We'll do a cut down the middle. This might not be a good idea to do so early, but I want to make the legs, so we'll chop this in half. UF, fill in the selection. UI, delete everything else. And now let's make a couple of legs here. Maybe it can also be like a lizard. Letter I for inner extrude. Maybe perhaps pull these out a little. D for extrude. And then are we going to make them kind of like, I mean, it's a bad idea to do this without Abdo, hi. And Bahines? I'm not sure. There's a couple of different pronunciations we might do there. But yeah, Whaley, that's old school. I can't use Whaley anymore because he's a grayscale gorilla. But I'm thinking it might be a good idea to, one moment. Yeah, that's there. New window. Okay. I just go do a quick search for, I don't want to be too derivative of that. Let's just, I'm just going to search for a picture of a dog. So we're just going to look for an image of a dog, and I just want to see the way the legs kind of generically look. There we go. Nothing fancy there. So you can see I'm looking at this dog. So the way that I just want to have an intuitive feel for the bend of the legs here. So we'll have those kind of point down. I know it'll go out, but I'm just going to model it as we go. I don't know. I'm worried that I'm thinking of this wrong, but that'll go down. That'd be the knee, and we can go down again, and it's kind of the foot. If we did a loop selection there, I could pull that forward just a little bit to indicate kind of that knee for the front leg. And I don't want to go too crazy on some paws and or claws, but let's see. I'm going to do an extrusion of D. I'm going to do an extrusion of 0. Here's a neat trick. Extrusion of 0. And now I'm going to hold down Shift and select the points. And now I'm going to deselect these back points. I have to turn off my selection tool and select those. And now if I hit T for scale and scale them out, you can see I've now created this triangle wedge. And now if I select everything UO, or is it O? No, yeah, UO, then it optimizes and re-welded those back points. So we did introduce some triangles, but now you can see I was able to get this nice wedge shape going. And now with that, I can create some little claws. Maybe pull, oops, turn this back on again. Always do that. Pull these back. Maybe scale them out a little bit more. Now we grab these. D for extrude. Don't preserve the groups. And now we can pull out pull out 3 different toes. Cool. Now I'm going for the most generic kind of overview here. We'll see if we end up smoothing anything out. But there's a cute little foot. And now let's make the rear leg. That one's going to be a little beefier. So hit the loop there. T for scale. Scale on both axes. And I'm looking at that dog picture still. So we can grab this, do D for extrude and pull down. We'll scale it properly in a moment. And then D. And then this one pulls back. We can grow our selection. UY. Pull that back as well. And then if it was kind of being like a dog, we could rotate this a little bit. And then that kind of becomes this extra foot section. Now we could bend it, but I can also do that, which is kind of what I was going for. Now I want to do that same claw trick. Let's flatten this out. And I guess I'll do the back foot a little bit differently I'm going to super flatten this out. And I'll do the back foot just a little differently where I'm going to extrude again. And now we can do that extrusion trick I did there. De-extrude for 0. Convert to points. Deselect. Deselect. T for scale. Scale them out. And pull them back. Optimize. Select all. UO. They're re-optimized. Everything is reblended. Grab this front one. T for scale. Scale that in a little bit until these are all even-ish. Select all 3. D for extrude. I said D for extrude. I'm having my keyboard might be running low on power because I've been getting some little bits of lag. So yeah, that's kind of what I was going for there. Cute. I will do a loop selection here. UF, fill the bottom, pull this down a little bit more. I just want this to be a hair more even. Pull this up, and you can keep on going and make these a little bit skinnier here, and the different parts of the foot could, this could be a little bit beefier here in the back. Things like that. So we can just keep on going and going and going if we were so inclined. Let's keep pushing this tail out just a little bit because, well, I mean, we don't need too much extra geometry. So you know what? I won't scale that out more. And just for fun, we'll do a little bit of scaling on the overall body, but I think I might do the symmetry now. What am I doing? I'm doing a symmetry. Boop. Correctly mirror. There we go. So we've got this. The feet are just barely intersecting, so not too bad. I would have thought that would been worse. I'm going to do a loop selection there, a loop selection here. Fill my selection UF there, and hit UI to invert, and now I can scoot these both outward that little bit. Looks like somehow those got disconnected, which is strange. So we're going to re-optimize the points. UO. I'm going to hit U Shift O actually, and here's our optimizing. It looks like it's correct. So now if I pull it, there we go. You see they're connected. I must have clicked something to disconnect them. Oh, Abdo's asking, yesterday at the meetup, I won a $100 gift card for Grayscale Gorilla. So I didn't keep it. I redrew another name so that someone else could actually get some value because obviously I've already got everything. Let's make this belly a little bit fatter. I don't want it getting longer on X. So I'll turn that off and I can scale a little, grow, scale a little, grow, scale a little bit. And we'll kind of do the exact same idea back here. T for scale, scale down, grow, scale, grow, scale, grow, scale, grow, scale. There we go. It's looking a little bit more like a lizard than a dragon, I gotta say, but hey, that's fine. It's all in the head. Yeah, and speaking of the head, let's see. Let's make something. So that would be the neck. We can give it a longer neck if we want to. So yeah, we continue the head here. So assuming these are properly connected, and I do want to make sure because that could be bad. They are not. Ooh, that was close actually. So I'm thinking, let me see. I'm going to delete these 2 polygons, And yeah, there you go. You see there was this problem in the middle. There's only that one right there. So I can delete that. Actually, I can hit undo. And did I just do that extrusion? Yeah, I did that extrusion. So these are not welded. Again, we're having a lot of welding problems. U, O should be welded now. D for extrude. And now if I delete that, oh, it's still there. So somehow, for some reason, these points are not getting welded. So I don't trust my, I hit U, Shift, O to pop open the menu. I'm just going to do a bigger tolerance so that everything should get super welded together. Oh, I'm being dumb. That was probably all fine. I just turned off preserved groups and I forgot. So dangerous thing, but there we go. Fixed. All right. If we were making something a little bit rounded, he's a chubby boy. Yeah. Maybe we could even pull the belly back a little bit more, but chubby little dragon. That's fine. Okay. So let's see. A loop selection. I am not going for like amazing edge loops or anything, but I would like the poly counts to be what would be reasonable for a character. Let's see. I don't have a plan here, so let's try doing extrusion here to make the head a little bit bigger. And you see I have it above 91 degrees so that these are turning into these angles. That should convert those shapes well. And now we can start making things a little bit more rounded. If I pull this forward, grow the selection again twice, pull that forward, that's going to round out this entire overall section. And then select, I guess grab both of these. Oops. Both of these, T for scale, scale down, just round that out a little bit. So you see I'm kind of converting to more subdivisions there. Now, we're going to need some sort of mouth here. In fact, I feel like I should scale that up a bit. And let's do a big cut right there. MF, do a cut right through the middle. It's kind of like a knife tool, but it automatically places them. We've got this shape, which we might need to chase around. But for now, I'm just going to melt it or dissolve it. Let's try dissolve. The shortcut now is MN. So there we go. Got rid of that. And now we can extrude the mouth. So I'm going to, let's do a little extrusion here. And then I'm going to do identical extrusion there. And now I've got two of them. They're each doing their own thing. So I can pull this as far forward as I want. T for scale. Just pinch in like that. A little D. And now I can't extrude both of them. I'm not even sure what I'm going for here. I don't have a character design in mind. I'm really just seeing what I end up with as we go. This isn't meant to be like some sort of final character. I'm going to be missing the point in the mouth, but if we just pull that down a little bit, you can see what we've got. Grab that, pull it down a little bit more. He's looking more like a lizard than a dragon. And I guess until we put wings, everything just looks like a lizard. So we're just doing something like that. He's definitely got a little bit of a lizard thing going on, but hey, we don't do too much modeling and I'm having fun. So let's keep going, spend some time making this maybe a little bit correct. I'm going to add a bit of a frill here on the head. So I for inner extrude, D, we'll do that. And then maybe this whole thing can pull back a little bit. There we go. That's a little, I mean, there's still lizards that do look like that, but it's slightly more dragon-esque. T, goes in, grab these, pull it up. At any point, you could do the symmetry object, but I gotta tell you the truth. Like most of the time, I don't make a symmetry object. I just do these kind of mirror-based things. It's so easy to do a selection on one side and then do the equivalent on the opposite side that I tend not to feel like I need to do the do the symmetry object, break it apart constantly doing the symmetry. Now, I mean, essentially what I'm kind of trying to create here is only the parts that we want to cover in scales, because we can keep on going. But if we go too far, then we start getting really detailed and only certain parts should get scales. Round all those out a little bit. Loop there, T for scale. Polygon selections. I'm going to make him a little, let's make him a little bit fatter towards the tummy. Yeah, there we go. Just not quite so even down the center there. So yeah, he's looking pretty weird. I like him. So we can round him out. And yeah, he's not quite as nice when he's all rounded. That's not surprising. It happens to me all the time. I do the modeling inside of not a subdivision surface, and then once I put him in the subdivision surface, it's like, ooh, he's not nearly as nice looking as he was a second ago. We can fix some of that by getting some of these, at least this front one. I'm going to hit MG for the iron tool, and as I click it, it's going to really round those out quite a bit. If we go too far, it's going to get really curvy, but that's fine. I mean, honestly, his shoulders should probably be a little beefier. Not that I know much about anatomy, but we could just give him a little shoulder strength there. And then we can do the same rounding right there. Grow the selection, deselect, MG, round those out, MG, round it out there, better. Do the same idea here, select those, pull it up into the air. He's weird looking. I like it. Pull it down there. He's going down on the belly more. The tail, the body's a little bit long and the tail's a little bit short, so that's kind of bugging me a little bit, I gotta say. So we're going to melt down one of the segments here, UL, and dissolve it, and then we've got one extra long one. So if I do a loop UF, grab the entire part of the body, and I can now scoot it back. Well, tons of this is eyeballed, so I don't mind not having it perfect. But yeah, there, I've gotten rid of one belly segment. Honestly, I feel like we can go even further. Another dissolve, MN. Okay, just there. Overall better shape. The tail definitely needs some more length on it, but I guess the polygons are squishing as well, so that could get weird for the scales. Let's see. Yeah, it could just be a Komodo. I mean, honestly, we shouldn't be spending nearly as much time as we are on this. Is fun, but MN loop UF, grab the top, pull this in. Now we need to, let me give him some sort of indication for our eyeballs. Where should the eyes be? Beady eyes on the side. Kind of feel like they should be right here in the middle. We can do that if I select that point and this point and hit MS for bevel. That now we could bevel those, and it's going to explode those out into these. Now we are creating n-gons around, so we do have to be mindful of that. But we typically spend our time more near the end creating the final mesh that we want. The topology is the actual word I was trying to say there. And then you could, we could do little eye stalks here. That could be weird. Or an eye pit. I don't know. Not amazing. And it'd be nice to do a little bit of curvature. Let's try a U. Let me see. UL? No, that's UM. Yes, I remembered. This is a path selection, so I'm holding down. I can just draw out a path here. You can see I'm traveling down the body. So I could just pull all these up a little bit, give it a little more curvature. Terrible eyes. They probably should be have more sides to them. This ridge is bothering me. Maybe we can melt it in. MG. That makes him look more like a lizard. Well, not amazing. Not amazing, I gotta say. But maybe good enough for what we're doing. Now, hang on. Let's get a little warm. A little more air. Oh, boy. Do a video about a banana. I don't even know what that means. Here's the thought, is that if we want to put scales all over, let's create a selection of every place that the scale should be. So I'm going to select everywhere, and I don't want the scales on the eyes. I don't want the scales in the mouth. Maybe not even like here. This would be like the nostrils. So, we won't worry about that, but that's potentially another place. I think we probably wouldn't want scales on the bottoms of his toes, but I think everywhere else could get scales. So that's just an idea, but this is also a test in seeing if we can stop the scales from not being in certain places. Okay. Now I will set a selection. Name that scales. Now, we should take a look at the topography a little bit. So pretty much what is our, I'm going to subdivide him by 1, hit end B. And now this is what he's currently looking like. And now I feel like the smallest the polygons get probably are around the size of what are on his toes there, maybe around this ridge. And then they get as large as they are here on his belly. Now, on one hand, it's like, oh, I want to make it a very, very even topography. But on another hand, what I'd like to do is experiment with them being a little bit more uneven. Like, you know, what happens if it's larger? Like, can we work with that as a limitation? But yeah, but Didi, you're saying do a banana. But like add scales to a banana? I don't know about this guy's already a banana shape. So I'm going to go with that. All right. So let's just say that we've got our mesh here. It's not exactly a dragon. Maybe he's got little, maybe we can give him little baby wings. Yeah, we'll do that. We'll give him a little baby wing. So I'll do that. T for scale, scale it back. I guess the wing should maybe be a little bit more by the shoulder. This can support his weight better. He's got to be anatomically sound. Another inner extrude. Yeah, I mean, inner extrude is the same as an extrude. And I will do a symmetry on him after this. So pull that up. D for extrude. Pull up another one. I can get a little skinnier. D for extrude. And then I think I'll do one last extrusion. And then we'll change the direction here. D for extrude. And pull it. Oh, stop doing that. This. I might not need to hold D for extrude because now you can just hold control. But, you know, we'll just keep that in mind. R for rotate. I'm just going to rotate a little. Grow. UL. T for rotate. I know it's going to be twisting it away. I don't want, but it's fine. I'm not that worried about this. I just wanted to angle these a bit. There we go. D. R. Down. There you go. Cute. T, D, T, down. All right, there you go. That's his little wing. Now, obviously, there'd be you know, like a wing fiber in here. We can generate that as a separate piece of mesh. I will hit UP to split that out as a separate polygon here. And now this can become the wing. I'll worry about, well, we'll do a very, 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 very basic one by hitting the midpoint MF, cutting straight down the middle of those. And now select all, shrink, and now I get my middle line, except for the 2 edge points. I don't even, yeah, we'll have it go all the way down. And now I can just hit D for extrude, and I think, yeah, you see it's pulling out that way. If I hold down shift, I can spin the direction. So I just want to do something like that. Then MG, nope, that doesn't work yet. I'll just do another extrusion, but this time I want no edge rotation. And then one more, that's fine. And then now hitting that loop, grow, UI, delete those. Now we just have this little wing section, MG. I don't want to do on the outside though, so we will deselect these, MG, and this should start rounding those out. Got to be careful. Yeah, nice. That's exactly what I wanted to have happen. Just got to pull these in a little bit. In, grow, in, grow, in. Yeah, not perfect, but cute. All right, we need to chop him in half, and then we can start doing scales. UL should be easy to do that. Selection, UI, delete. Symmetry. And copy paste the symmetry. Make a wing symmetry. Yeah. Now we've got a little dragon. A dragon is as simple as putting wings on a lizard. Adorable. Let's save it. Episode 5, Scene Files. By the way, everybody on Patreon, if you're at the engineer level, you get these scene files. I like putting the number in the beginning. This will be 1A Dragon. Good enough for me. All right, so when we're doing the mesh, we are going to be combining them, so I will just bake that down immediately. This will be the dragon. Now, once again, looking at our point count, we've got, I think that's all working well. Let's see if our selection is still good. And yeah, the selection, even though we just deleted half of it and copied it over, it's all super working except for the top of these wings. Although I do have to say, I do want the wings to be getting scale, so I'll just fill those in. And our selection was still pretty good, so I can just reset my selection while it's selected, say set selection, and there we go, it is reselected. All right, now let's start moving into generating some scales. So even though we've got this nice dragon, I'll make a duplicate of it and hide it, so we can always go back to that. And now we want a subdivision of it that's going to round it out, and we can see what our distribution is. Now, I wouldn't be surprised if we want to go another level deeper, so it's going to have a lot more scales. In fact, I can already almost 100% assume that we're going to want to go at least this deep with it. So let's make that assumption. This tail, I gotta tell you, I know we're just trying to go, but we spend a little bit of time modeling. Tail's got to be fatter than it is. It's just tapering down too much. It's a little lumpy, but at least it's not as skinny. It's like a dragon duck, the terrible head. But so with our terrible dragon, but he's also adorable and wonderful, so we love him. Bend his knees a little bit. You got to bend at the knees, dragon. So with that selected, with this made, let's bake it down. I just did a bunch of changes, so we'll make another one. All right, so I'm gonna make that down. So now we've got a subdivided dragon, subdivision dragon, with a selection that should be everywhere that we do want scale. So we need a scale. Yesterday we did a fine job using our Bezier. So let's do that again. We'll subdivide it very little. You know, I did something bad, which is Z forward. It's always a good idea to model things Z forward, like the face of this should be looking to the right. It's just going to keep everything a lot simpler for us if we do that. So I'm going to grab everything relevant and hit R for rotate, spin it 90 degrees, holding down shift. And now we'll just pull these out. This is the only one I'm worried about. And then I'm going to take his axis and set that to 0. So there we go. He's now rotated properly. All right. So with that in mind, we can take a look at our Bezier. And B, actually, we're already seeing subdivisions are not too crazy. And now we can just use point mode and select and get some nice curvature going. Pretty simple. Like I said, one of the reasons I like using this is we can select all the points, push this up in the air by 200 units, and now it is pivoting from 0, 0, 0. And the other thing that's nice about doing this type of thing, pull those out, maybe even get a little more bulge in the middle, is parametric, even though it's kind of like a parametric object that we still have access to the points. At any point, we can add some subdivisions here, and you can see that it would make it a lot smoother of a scale. But right now, we keep it super low poly, so it's only 4 polygons, each with 4 sides. So it's a nice quad. And the axis is right at 0, 0, 0. It's also exactly what we want. So T for scale. Scaling it pretty tiny. What color dragon should it be this time? I'll leave them white until somebody calls out. The first color that somebody says is the color we'll make them. So, okay, so like I said, I would like to spend a few minutes trying to figure out how to get the target effector working a little bit. If we clone this onto, put in a cloner, put the cloner, oops, someone got in with blue. Good job, Shane. VFX King, what's this stream? I mean, it's not public, is it? I thought I said it's not public. Do we have a lot of people who are just in not from Patreon specifically? I thought I had said it properly. Oh, it is set to public. I'm changing it to unlisted. Well, anybody who snuck in, you successfully snuck in. So yeah, this was supposed to be a secret bonus stream. We're trying to explore the scales more. So welcome anybody who made it in. Okay, so we're going to set this to object mode. The object is going to be the subdivision dragon. And then we're going to limit it to the selection. And then we want to clone onto, let's say, polygon center. And it's going to make a whole bunch of them. It's going to be real messy. I'm going to set it to multi-instance to begin. Now, here's where we need to start getting the target effector doing something. Pretty ugly. Oh, yeah, and we're making the scales blue. Maybe we can make them let's make them like a Fresnel blue. That'd be nice. We'll go from a light blue to a nice dark, almost purpley blue. Yeah, just a little something. All right. Okay, so these are all, the orientation on these is not amazing. Now we're going to be changing the orientation a lot. In fact, I'm kind of inclined right now to put this into a null. It's going to create a lot more objects, so it might slow it down a little bit, but let's not worry about that quite yet. All right. Now, you know what? We want to be, let's do a testing protocol. Let's do a simplified scene. Yeah, we'll just start with a sphere. And I want to clone a bunch of cones. I'm going to do a bunch of 3-sided cones. T for scale, quite skinny. Clone onto an object. The object will be the sphere onto polygon center. So right away you can see that the initial problem, and also this needs to be in a null, so that I can pull all of these upward. I think that is where they're at. The initial problem is that the orientation is wrong. So we could change this rotation, but I always feel like that is a bad idea to change the rotation like this, because we're introducing another level of like rotations introduced into the entire system. So instead of rotating this, let's make the actual object we're feeding in be the proper orientation. So that's going to be Z plus. Like I said, Z plus is forward. So that probably means that this needs to be on Z instead of Y. And there we go. Now you can see they're pointing the correct direction without us having to do a internal rotation. So these are all rotated, looking nice. And I'm going to scale them, which actually I guess we can make it a 4-sided rotation. And then I will scale them to be extra wide on X. Yeah, so now they get pointy. So, you know, it's a facsimile of what we're going to be doing. So what I want to do is, these are all pointing outward, and this is doing a good job because it's a nice clean piece of geometry, so it doesn't create all these weird angles. But if we are to make that editable and start doing maybe a couple of knife cuts here, and maybe select it all and triangulate, and then let's shrink our scales. Now you can see that we have, and even that, okay, so that, you get that. You can see how they're all kind of random there. If we wanted to, we can even select all of our polygons. And if I hit U, Shift S, we can open our subdivide and click on Smooth Subdivide. And now everything's back to quads again. So if I were to hide this, you can see that everything is stretched out rectangle. So essentially, we've given ourselves an intentionally bad-looking mesh. The point here is that all of our scales are pointing the right direction, but they're not spun the right direction. So they'll point outward. So this is where our tests of the target effector are going to come in. Now you see what it's doing by default is it's trying to point all of them directly at this. So that's their default behavior, but that's not what we want. They're already pointed the correct direction. So the target mode right now is target the object. We could look at the camera and we could go to the next node. We don't want to do any of those. Let's set an up vector of X plus. That spins them around. That's interesting. That spins it around as well. All right. I wish I had a better intuitive vibe for target effector. That's why we're here, though. This was the bonus stream. I know a bunch of extra people made it in, but the this is what we're trying to learn, is this, because we're not certain of what we're supposed to be doing. I'm trying to do it with a target effector instead of the technique that we do know works from yesterday. So if I turn off target object, that doesn't seem to do. Oh, if I turn off use pitch, rather, it's now no longer targeting. That's not what we want. Then we could change an up vector, and this, that seems to almost spin it straight down. But let's keep pay close attention here. You can see that they actually are all rotated in the same type of orientation. That's not a bad thing. You see that all of them are lined up. They don't feel like they're randomly spun anymore. So now right now, the weird thing is that changing the up vector, and the up vector should be the direction that it thinks is up. But what does up mean when it's aiming at, they're all aiming there. So then the up vector becomes their secondary axis. So if they're all aiming up on Z, then if we say that we want them to go on X, I would think that this would still be perfectly aiming at our current target and not facing away. So that is what's throwing me off. And clearly Z is what is aiming. If we put this back to none, then they all aim straight there. Now up vector, yeah, it's very strange. Z minus, yeah, none of them are working. Reverse heading. I'm just clicking buttons now. All right, those are not amazing. We say look at camera, that this aims at us, and then we can do next node, previous node, but it's going to spin them all super randomly. Object target, and target in this kind of thing, I would think, is pretty much what we want to do. But now what I suppose we need to do is say to use the field direction. But even, you see, I don't want to say field direction because I feel like we haven't explored the limitations of what we are doing here. For instance, I want to see if changing this rotation, no, changing these rotation doesn't change anything. But we do have that initial rotation. So I'm actually going to put this into a second null. And that way this is pivoting from the right spot. And now we can do things like put a 90-degree rotation there. And then by changing that rotation, you see that that's now aiming off in this direction. So we do still have that as a variable. So we're targeting the object. And then as we change these orientations, oh, it's scaling. We're not getting the width scale because we changed that orientation. So just something to keep in mind. Oh, look at that. Okay, so now look. Okay, so now I did, I've just been clicking randomly, but we did a rotation inside of our null, this one, and we rotated 90 degrees on H. And now, look, they're all aiming outward, and now they're all aligned properly. Now they're all lining up. So you can see that we did essentially just do we just did the effect. We got a lot of people watching. Well, welcome everybody. This is a bonus stream. Usually this is only for Patreon, but welcome to the extra bonus. Okay, so they're all lined up and they all have the proper orientation, but I don't have an understanding of why that worked. So if we set that to X, and then we set, that's X, and then X minus is going to be the opposite. Y plus aims them all inward. Y minus will probably just, well, Y minus is fine. It aims them outward. Z is just going to be another orientation. So Y minus, oh, and here they spiral. Like there's several combinations here that feel like they're almost kind of doing something. So all of these are aiming outward pretty well. I mean, they're all kind of in an absolute way, so it's not as useful. I can't make a tutorial if I don't have an understanding of it. But now they do spiral out in the correct direction. And once they're spiraling out in the correct direction, we could add additional effectors just to have everyone know where we're heading. I can add a plane effector and tell it not to affect the position. But now if we turn on rotation, I can rotate all of these like that. Yeah, you can see I can twist them all a little bit, and then they can start overlapping in a much more scale-like pattern, and then we could have them start lying down flat. So we did get all the nice orientation here by rotating the internals of the cloner and then letting the target go on y minus, but that's, I mean, that's completely arbitrary. I think having, if we did a different vector and a different rotation, that would also work. And I just don't have an understanding for why. Why? Um, so I guess what I want to say is like let's try pursuing the same hair method we did yesterday, and I want to see how well that works overall. I do want to spend more time playing with target, but I don't want to do that right now. All right, so we're back in here where we're cloning the scales onto our lizard dragon. Grabbing our subdivided dragon, I can create hairs. So simulate, object, add hair. And now we get all these hairs all over the entire critter. I know we're not doing the mesh being inverted. We'll do that step later. So we get all these hairs. A couple things we want to do. First of all, segments 1, length can be whatever. I think it would be incredibly tiny, but 10 was working well for us yesterday. So you see we just get these tiny little hairs. Now, I don't know if there's actually a difference right now from letting them grow where they are. They're like this. But in any case, I'm going to go to hairs. I'm going to say I want the hairs to match as guides. So now there's exactly one hair for every guide. And then under dynamics, it's not dynamic anymore. Under generate, don't make hairs, but yes, make a flat polygon. So there's a tiny little polygon on the side on every single one of these. Now we need to be way fatter. So I'm going to go into the material, go into thickness, and make a width of, I don't remember what it was yesterday. Let's do 2020. Yeah, 20 is a good number. So now you can see that we've got a single polygon that pivots from right on the ground. And that is now creating, it's essentially cloning. But here's the difference, or at least what hair was giving us yesterday, was we could get a nice flow on these by choosing the alignment. And before we said X, but now I think we're on Z. So I'm going to say look Z. No, I guess X is still the correct one. Yeah, so they're trying their best to go along the X-axis. So you can see they align with the X-axis. So this is going to work great on almost everything, except it's not going to travel up along that surface here. It's going to keep on trying to aim it backwards. So that's good on one hand, and it's not good on the other. Also, I think these hairs should have been limited to a selection. Let me see if I can do that. Dink. Regrow. Yep, that worked. Nice. It got rid of the hairs on the places they shouldn't be. So that's the problem. That's what we were kind of talking about before. So that is our orientation. It's local, but there's no additional settings to do anything to fix that. That's just where they're looking. Now, having done that, I'm curious if we can paint these. Simulate hair tools and grab a brush. If I were to brush these down, yeah, you gotta be careful because they're still trying to orient themselves along the Z. So we do have some options as far as like trying to fix that flow a little bit, but currently all of these want to orient themselves backward. I mean, it's not inherently a bad thing, but how do we control it? How do we control it once we want to go vertical on something like this wing pillar? Now, I guess something you could do is grab that would work, but you could make multiple hairs. You could make one hair for like the vertical ones and one hair going for the back. There's no flow currently, and this is even generating. These are all looking in a particular direction. We could say random, and now they're all doing whatever they want. It's local. So yeah, actually, maybe even the local is why the Z was relevant, but regardless, that doesn't matter. So yeah, I'm trying to think of where we go from there, where we go next. How do we get better orientation? And is there any way, yeah, these are just straight up generated, they are what they are. So we can't do things like get the scale from these because they're all the same scale. And I don't think there's no, when we go here, we can turn on scale, but the scale doesn't have any reference to anything else. And we already know that the vertex maps don't work here. Let me think. Because we could make a force, but remember the way we were generating the force earlier, the force that this all follows was by using these, like the direction is being chosen. This is what makes the force direction. So we can't use this to generate the next force direction. Having said that, I just had an idea. I don't know if this would work. If we actually make them dynamic, how do we choose a direction? Free. All right. Well, we got to do some tests here, but I have an idea that might work. It'd be a little bit artistic, so it'd be kind of fun. So here is a basic idea. We're gonna have to build it though. So I'm gonna make a helix, and the helix I'm gonna make into just a nice straight line. It's a parametric straight line that pivots from the start. So you now see I've got a spline. I'm gonna pull it up here. You can see it aims backward, I think. So if I hit T for scale, I can let it scale, and then boom, it pokes out the tail. So we've got something that's traveling through the entire thing. Excellent. Now we're gonna make a field force. Simulate forces. Yeah, if this works, it's a really neat idea. Field force. So we're going to make a field force, and we're going to feed in on the object tab this spline as the field force. We want to see the field force. So under display, I'm going to say, don't worry about the vector. Yes, give us lots of preview. Don't worry about X. So X, Y, Z. This becomes 0. Crank up the size. And I'm going to add a 0 onto there. Let's even put another 5. There we go. 6. All right, so you can now see we have a visual representation of what direction we should be getting. Now, inside of this field force, we have fed this spline. As long as I'm going to crank the power up here. Yeah, I guess it was double length, so let's make sure I'm going to position that better. There we go. We didn't need quite as many. 3,000. All right, so you can now see that we've taken the orientation of the spline and it's traveling along the spline. Now, that's giving it a wind as a direction. All this is the equivalent of all the field force behaving just like a wind and saying blow backwards, possibly forward, but I think backwards. So the hair should automatically see that if we turn on dynamic. I'm not going to worry about collisions though. So I just want to see what this does. Let's save it as incremental and hit 1 frame forward just to make sure it's not too laggy. Seems all right. All right, hitting play, and not much is happening. Now forces, it's excluding, and there's a gravity. That's not much. Now they are dynamic. They're dynamic, and right now, let me think. Right now they're free, local. I gotta see some movement here. Random, object, look at. I don't want to do that. Although that's also interesting. Look at object. Oh, I think that might just target everything. It's probably just like putting a null. Yeah. So that's another interesting way of getting a position, but that's not what we want. Okay. How do we... They're not moving. They're not bending because they're dynamic and they're not colliding, but they don't have that many segments. So let's try giving them a few segments. 5 segments, and now they're subdivided. So now let's see if they, okay, now you can see that they actually do bend. So I wish we didn't have to do that. I'm going to give them a single segment, so they're subdivided by 1, which might give them a little bit of wiggle. And now they can maybe fall a little. I'm going to say forces, no gravity. We have forces, they're not excluding anything. So if I play, then not much should be happening. Now this field force is very weak right now. Let's crank it up 10 times as strong. And 10 times as strong again. Now you can see they're all blowing forward. They are doing that. Now can we drop that back down to 1? And do they move? They kind of are a little bit, but not very much. I'm going to put the wind even higher. It's just making them vibrate, but it's not really picking a direction. So let me think. Can we give that one segment and then drop the hairs down? Clone as roots. How can we get a direction from this? So the idea I have is so close. Think. That goes too far. I mean, we could clone onto a point, but that doesn't give us a direction. And that'd be really interesting. Weird. The whole point here is to get the initial orientation. I'm trying to get an initial orientation, and everything I want to do to get the initial orientation is the same thing I would do to get the deeper layer. It is unfortunate that there is no way to feed in a direction, and that these forces are not. I'm going to turn off don't fix the roots, but everything might fly away. I just got to play with settings. That's why we're here. Because there's extra people here, I'm getting distracted where I'm trying to like make it more entertaining and move it quicker. But really the point here is supposed to be that we go slow, we figure out what the heck is going on. So we're back to one segment, hit play. Not really. There's a little bit of rotation, but not much. The hold roots setting in dynamics is set pretty high. Yeah, well, I just turned off fix roots. But yeah, let's go ahead and good call, Zach. You 2 points. 2 points for Zach. The hold roots is the magic setting here, so thank you very much. So now I can go back to these being fixed roots, and now by setting the hold roots back, now I'm actually getting it to tilt a little bit in the direction I want. Don't think any drag. What's stiffness do? Not much. These are settings that I just don't typically. You just don't have to play with. So. So as we push this further, we can see everything is tilting in the direction, but we have to be careful because this isn't taking on the properties of the surface. So even though it is tilting forward, and by the way, we wanted this tilting back, so I should grab this helix I'm feeding. I'm going to reverse the direction, so now it should be blowing backwards instead of forward. Now we have to be careful. There's a lot of things we got to be careful of because while this is pushing backward, we're losing the rest of the orientation. Now let's see what we can do. Currently, generate, it's aligning based on the object. If I were to say a look X, does that override everything? So it's starting out. I didn't know local. Okay, local X. If I play, oh, okay, it does. Okay, good. This is good. So I set X. X was good. X was giving us a general orientation we wanted. This actually might be in contradiction. But now if I play, you see that all those will blow backwards. Now we do want them to blow backwards, but we don't want them to be too crazy. So we need some hold because we do need them to maintain some of their angle. So how far do we need to go? So yeah, somewhere in the 25 range seems to maintain their general place, but it does tilt back a little bit. So that is good. But okay, well now the question turns into they're tilting backward, but let's say that I'm going to rotate my helix upward. So now we've changed the orientation to aim that direction. What happens to these in that case? Yeah, unfortunate. They don't spin to go in that direction. Oh, if we could just tell these to take on the direction of a field force, that'd be really good. Can the target can tell things, the target object can tell things to take the orientation of a field force. I really want these to spin. If they tilt one direction, I want them to spin that way. But I want them to have this basis that they do. It's kind of like I want the best of both worlds, and I don't even know if that's a realistic thing to have. Local, what does that even mean? That's probably world now. Yeah, they'll tilt over there, but I need them to orient. So the alignment An object is just going to try and look at an object. That's not what I want. I mean, it'd be great if it looked at the mesh of a second object. I don't think that's what it does. But you know what? For the sake of experiment, let's find out. I'm going to make a second one. This one, I'm going to set to a render tag display. Set it to lines. Okay, so we have a second dragon. And what this one is going to do is be the look at. I don't think it looks at the points, but that's what we're doing the test of, because if it looks at the points and I move this upward, you can see this moves up, but you can see that they're not tilting on the individual polygon basis. They're tilting based on the axis. You can see as this axis moves, it's spinning around there. It would have been neat if it was aiming at the equivalent point, but that is not what happens. Let me think. Where am I at? I'm trying to do something very specific, and we're trying to make awesome scales is what our goal is right now for anyone who's not sure what we're doing. Tilts in the direction. How can we get... We could make two sets of hairs and make one a rail spline. That'd be weird. That'd be really weird. Does that make sense? A rail spline. But they have to be offset. They have to be offset to want to go down there. And then that rig would be insane. I can imagine a way of doing it, but that's way too complicated. The field force, we can build in general flows. How do we translate that to orientations? I mean, it is making me think that we should tinker with the target. Yeah, let's do that. Let's try jumping right to a target, because the hairs right now are not doing what I want them to do. So let's simplify. Let's make the cloner again. And in fact, I'm going to steal the spike from our other tests. Let's clone that. Nice. All right, so we get all these little spikes, and we'll scale them on X. Okay, so those are our, he's a very metal dragon. He's looking really tough. Okay. Now, this cloner is not seeing any effectors, so we add an effector. The effector will be a target. This is going to target the field direction. So the field direction doesn't have any fields yet, so it's just going in a direction. So I'm going to begin by adding in this helix, and that is going to serve as a direction in theory. Let's go ahead and offset that. Okay, so now you can see all of those are, okay, this is interesting because they are all aiming down. So I think that's what the helix, yeah, when you drag the helix in by default, that was saying they all aim down, which means if I grab this helix, this is interesting. If I grab the helix and I spin it, you can see that they'll all aim the opposite direction of where that's aiming. So that's good, actually. So the general idea is like, okay, most of these we want to aim backward. Negative, well, I guess it's 180 degrees. Now, a couple things we need to test. First of all, can we pull back on the power on this a little bit? If I pull back, can I get it to, yeah, they're not directly orienting themselves, but if we do that, let's just, they're all aiming backward. If I were to rotate them, I gotta think. Well, before I don't want to lose anybody, but here's what the next step is. Here's where the idea goes. If we grab our dragon, and I'm going to grab our path tool, UM, and for simplicity, I'm going to just trace up his wing here. We got to be pretty clean about it. If I trace it, what we're going to do is use splines as a way of creating flow directions. And that's actually kind of something I've wanted to do for a long time. And if we can get this working, it'd be pretty cool. So I've just got that one wing. So we'll just start out with the one as a very, very basic test. Shift, I'm gonna hold down Shift C, and then type in the word edge, and then here's edge to spline. So I double click that, and now you can see I've converted that edge that I had into a spline. Okay, good. I'm gonna drag it up here, and inside of the target, I'm going to drag that new spline as a direction. So here it is, that new one. I'm gonna turn off the other one just so we can see what we're dealing with. So if we crank this offset all the way, yeah, okay, check this out. Do you see how it is? Look, this is following the orientation of that mesh. That's a good thing. That's a very good thing, actually. So you'll see if I turn my other one on that this one is currently completely overriding that one. And we're jumping ahead a little bit here. Oops, what did I just do? If I turn that off, okay. Now you see this is completely overriding everything. So all the angles got messed up everywhere. But if we turn this spline and we add a mask to it, I can feed that spline in a second time as a mask of itself. And this time, instead of it being based on traveling along the spline, I set it to a radius around the spline. And now I can set a radius, and you can see as I increase this radius that with any luck, let's crank this up, and I'm gonna give it some inner power. There we go. So as I increase the radius, it is now transitioning the wing, based on the radius, it's transitioning these parts of the wing into that orientation. And these ones that are not part of it, those are still traveling straight backward. So the idea here is this is a methodology. This is a methodology to get a flow where we can make a series of splines and be like, in general, I want these to travel this direction. And in general, I want these to travel this direction. That is the idea of what we're trying to do right now. So we are pulling orientation from splines. That is very doable. If you're making even a relatively complex character, tracing a couple of splines around and being like, that's the direction I want you to travel. That's what we're aiming for here. So with this being the idea, we need to, after they get an orientation, and by the way, this was backwards from what I want, easy enough to say invert the direction, and I see those travel up and along it, which is very, very nice. I'm also curious if we can use any modifiers here. Is there any, well, there's decay. Do we have any kind of smooth or blur? I don't think we do. Yeah, there's no smoothing or blending of these. We just have the fall off. As we change the fall off of this mask, it's going to show how the transition happens. We can mask things out in some fairly sophisticated ways, but I'd love to blur these. I guess the way you blur them would be to, well, I guess these are in, that's interesting because the target is, there's not a separate field. It's using the fall off tab for it, which is also very strange. It's a bizarre methodology. So keep in mind, the only thing we're looking at right now is kind of his main body and this little part of the wing. So what I want to do is, after those are there, can we spin them out? Can I add a plane effector? Not change the position, but we're going to change the rotation. And can I spin these out to be spiky on the surface? Yeah, see, they're absolute right now. So nothing about the surface is carrying over. Nothing about the surface carries over. So that is what that's what I thought would happen. But with our slightly earlier tests, we saw that if we spun this stuff on the inside to the correct orientation and we kind of set the Y minus, that they did kind of take on the orientation. So let's try that again. Let's just do the exact same method. I can put another null in there, and now this can rotate to, let's go to object mode. This can rotate to 90 degrees, which is going to spin everything and look all weird. But then in our target, we're using pitch, but I'm going to say I want to go on y minus. And now let's turn off the plane effector because we don't know what that's doing. And let's check out what are these it's the dragon's still very punk. I like it. All right, let's slow down. Turn off the target. What happens? Okay, so without the targeting going on at all, we are currently just cloning. Yeah, that's not doing anything. We're currently just cloning onto the polygon center of the dragon, and everything is just spiking out, doing their own thing. Now, if we turn on the target, we are currently feeding it some relatively complicated things. I'm going to try and simplify. Yeah, I want to simplify. So I'm going to make a second target inside of here. Let's feed it just that target. Nothing else is on. I got to remember those are off because I will forget. Simplified target. Don't use a field direction. Just look at an object. And that means it's going to be looking at its own position, which is up here. And set it to none. Target 1, target, object, fall off. Oh, yeah, we got these fall offs. I need to delete these. There we go. All right, so now we're kind of back to a generic default one. So now wherever I move this, all of a particular angle is going to aim a particular way. Now, inside the target, if we set that to minus y, they're all aiming kind of upward. Don't want them aiming upward. I want... Okay, I just got to think. Don't... The field direction. We have two... Just so everybody knows, there's two axes we need to control. It's like when you're using a proper... If you're doing a proper target effector, you know how the target effector... I'm saying target effector. If you're using a target tag, you know how there's a target object and a target vector. That's what we're trying to control. I'm trying to control one and then the other. I want it to aim straight out from the body and then get a secondary curve. And that is where I'm having the trouble. I'm pretty dang sure we can do it. I just have to think about what it is. And no, Shane, we're not going to do any espresso. But with field forces, we should be able to do anything we want. All right. Think. That is the target. I don't want to actually target that at all. I think that's what pitch does, is use pitch. I don't want to use the pitch. Maybe we need to do 2 sets of them. That'd be weird. That's not wrong, though. I don't have it in my head, but if we can get them just aiming straight outward, and then we use the pitch. Now, I thought that's kind of what we were doing. I'm going to go back and zero out that so that they're all aiming. Yeah, now they're all going to aim. Are they aiming straight backward? Are they following the topology? No, they're just straight backward. Well, they're not straight backward. They're aiming backward here on this one. That's not what we want. I mean, the trick here, Shane, is we're trying to do it with effectors so that we can do it on every clone. It would be easy. It would be trivial to do this on a single object. It's not trivial to do here. So what we need to do is what I'm saying, those 2 steps. So I think we might need 2 target effectors. One target effector to say aim outward, and a second target effector to say rotate your secondary angle to this angle. That's what we're going for. That's what we're going for. So with that in mind, I mean, on some level, I almost feel like if we just turn off the target effector, they're all aiming outward. So, okay, fine. They're all aiming outward. Now, if you turn the target on, I'm saying I don't want to change their pitch, but you see that is where they aim. They still are the pointy end is what's aiming even without pitch. So is pitch the equivalent of up vector? Because that also says pitch. What does pitch mean here? I don't actually have, I got to open up the other cinema. I don't have the help document here. So I'm going to search for help inside of the old cinema. So let's keep it simple. MoGraph cloner, and then MoGraph target effector. And what does use pitch mean? The clone's z-axis will always point towards the target object. If it's not active, the rotation's pitch will remain unchanged. An up vector can also be set. Okay. If it's activated, the clone's z-axis will always point towards the target object. If it's not active, the rotation's pitch direction will remain unchanged. I mean, that's kind of what I thought was happening, but why? How does that explain the effect that we're getting? If we say use pitch, and then we say none, they're all aiming right there, no matter what they're aiming at this object. Fine, fair enough. And if we say don't use pitch, then that disappears. And now they're all just, I don't even know what they're doing there. As I move. Okay, yeah, okay, yeah. So what is spinning now? Do you see how they're all flat on the ground? So what axis is that? It's a hard-coded axis. Which way is up? I'm going to drop this to be three-sided. And the way that is up is not the pointy side. So if I were to pull this out and pull this up, then the direction that it's pointing is not the pointy side. So it is x minus is the direction that is currently. It's pivoting around the x minus. That's weird. Okay, so if that's pivoting around the x minus, then we want this clone. That is the x minus. That is what it's pointing on. We want that to spin, which means we rotate this up that 90 degrees. I guess that is the 90 degrees that we had been rotating before. Okay, we've rotated that 90 degrees. We put that back in again. Now, if we turn on now if we take this, it's going to, I thought that would, that's still spinning, but it's on a stable axis. What did I do wrong? If I spin that, I'm just going to start typing in random numbers. See, that all aims upward. I don't want them to aim upward. I want them to aim based on their original rotation. How do we give a primary rotation? Primary rotation. How do we give it like a, I want to aim X at something, and I want to aim Z at something. Reverse that, actually. I want to aim Z at something and then aim X at something. But I don't feel like we get that option. If I say I want to aim Z, but we need everything to be on Z, is our current rotation Z? Turn off the target. That should be all aiming outward, which means that's, and this is on Z, so this is currently aiming on Z. So I want Z to aim at something. Does the target effector allow me to aim at Z? If I turn off pitch, they are aiming one axis at Z, but that's not what we want. Use the pitch. And once again, object. I swear I've done something along these lines. Not to this crazy extent, but I've done something along these lines. Zach, the reason we need to use the target effector is because we need it to. The target effector is what can use fields, and you can see that if we turn off the target effector, that this is nonsense. We don't have an initial direction. We can't just pick one. So everything's got to be relative. It's got to be relative to what they're doing. I know we're not furthering what we did yesterday. We could go and do the same version as yesterday. We're trying to learn new things, so that's why we're not. For anybody who's coming in, I'll just pop open that same scene file. Here's what we succeeded in making yesterday. We're trying to make a better version of it. So you can see we get beautiful scales. These are all geometry-based scales using dynamics. They're perfectly overlapping each other, but these all face backwards. We're trying to make it so they don't have to face backward. We want to do it so they can follow the general direction of the mesh. That is what we're trying to solve right now. So, okay, everybody's on the same page. Back to Lizard Dragon. No, that's the target tag. I was like, what is that? If they're currently all aimed they're all aimed outward. That's cool. If we say that's not even on, they're all not going to be aimed outward, and there's no combination here that makes them aim outward. Now, we could, I mean, I don't want to do it this way, and I don't even think it's a good idea, but we could make them all aim outward by setting this to field direction, and inside of the fall off, we can feed it the entire mesh of our subdivided dragon, and boom, they are all going to aim outward because the oh wait, we have to change this to surface and increase the surface, maybe. And I don't want a fall off. What did we do before? Interesting. It seems like the surface is not calculating perfectly here, but I think a way around that would be to take our original cloner and poke it out the surface a little bit. So they're going out on Z. So if I tick this, yeah, okay, exactly. Sometimes I know what I'm talking about. So by pushing it just a little bit outside the surface, they're all going. And now this target effector is indeed making them aim. Well, actually, it's not entirely true. There's a weird kind of direction to them right now. So let's see. Target effector, it's taking on that direction. I don't think, yeah, that shouldn't have any effect on anything. Now, this by feeding it the surface as the direction, we're feeding it the surface, and this really doesn't need to calculate very far at all. I think it could just be 2. Yeah, 2 is enough to calculate all of them. Probably the smaller the radius, the quicker that will calculate. So they're all getting a direction from there, but that direction, and we can simulate the entire same thing by copying this and pasting it into our field. Not in the fall off. Do that all the time. Paste. Okay, so now it's on the surface, and if I were to expand this, you can see here, this is what's happening. Do you see how these become the directions? These are where it's aiming. So it's taking on the surface and should aim. But look, a bunch of them are still facing very forward. So that means the field direction isn't as simple. If I turn on use pitch, though, it looks like it's working almost perfectly. Of course, it's backwards. So it looks like pitch is perhaps an important variable here. But now you can see that they're all rotated in. There's a Z. I'm going to say none. There we go. None. So what do we got here? Now, I'm very interested in the orientation that they're picking up because they all seem to... He's doing a nice job of traveling along here. they're all rotated. We'd want to rotate them 90 degrees from what they currently are from there. But if you look into some other places, like, yeah, I guess they're all traveling along that way. So they're all the correct, mostly correct. Some of them are a little bit confused, but we might be able to fix that with increasing the radius a little. Yeah, the radius is perhaps a little small. And then even some are poking in, but that's, I understand those are happening because these are not triangulated. So scooting this out a little bit further there, they'll fix more and more of them for when they're confused. Okay, so perfectly spiky, all traveling out in this direction. They all have an orientation aiming outward from the surface. Now, that does seem to be different from the regular cloner, where there does seem to be a little bit more of a flow here, which is nice. But that it's a flow traveling straight backward, and I don't know why we're getting that kind of straight backward. Nothing about this. It's based on the field direction. No up vector using the pitch. Now, just for fun, let's try using some of these and see what we get. So x plus is forcing them all to aim inward, which means x minus should, or x plus, x minus, they both aim inward, which is interesting. We could probably just reverse the heading and they'll aim outward. What's the difference between these? Yeah, they seem to have spun essentially 90 degrees. Not everywhere. I mean, you can't trust it because like some of these are weird. Yeah, that's pretty weird and arbitrary. Let's try y plus, reverse heading. C plus would be confusing. Yeah, it's giving us interesting patterns. I don't understand what that means though. We've got interesting patterns, but I don't understand what causes these. And without an understanding of what they're actually doing. Oh, okay. The up vector is straight up z plus. And then, yeah. Interesting. So they spike out, but their long side, if I'm correct here, do I now understand that a little bit? If I scale this more, they're long. You see they're long on one of the sides. That long side is aiming in the secondary direction, which is the z. The z direction is just z plus. The z plus. So that's their secondary angle. If we set the up vector to be x plus, then now the long side is trying to aim along the x-axis, not a relative x-axis, an absolute x-axis. So our z is currently always pointing outward, and then it's trying to align the x-axis the best it can along the x. Now, depending on the rotation of the model, that's going to do different things. It's going to, like here, it gets confused because the x is very, like these are very flat polygons, almost perfectly in the x, which means x isn't distinctly up or down. And as soon as something tilts up or tilts down, it inverts the flow. So I think the point of our pinchy point here is going to be facing off to the right on one. And once we get to the opposite side, it would be on the opposite. Hard to tell, but yeah, I think these kind of go that way, but it might just be the angle I'm viewing it. It's tricky to tell. And then the y plus, I mean, I feel like we're aiming on y plus. I get, oh, y plus is going to have those generally trying to aim upward. You know, so a lot of those are doing a pretty good job. They get weird along the curves. Anyway, the point being is I understand what that's doing. Now, does that help us at all? Does it help us at all? Because what we really want to do is have these follow the field flow and then the direction. Now, it can't be as simple as that. If we, right now, they're currently saying that their flow direction is based entirely on the surface of the dragon, saying just point outward. Um, and that's the main direction it finds. The Z of the object. Yeah, that makes more sense now. I think I just suddenly understand the target effector a little bit better. The up vector, I always thought this was, oh my goodness. I always thought the up vector was saying which axis do you want to be the up vector. That's not what it's saying. It's saying it already has an up vector axis chosen. What direction do you want that up vector to aim? At the Y, at the Z, at the X? That's what that's doing. Huh. All right. Well, that makes this more sensical to me. I might be wrong, but I feel like that's what that means. But that's bad because I don't want it just aiming in a direction. I want to control the secondary angle with the field. That's what I want to control. I want to not control the pitch. I want to control the direction that the up vector is aiming at. Pitch. I guess that means use pitch. That means it doesn't roll at all. Okay. You think that takes over completely? I feel like we're so close. What I'm thinking is, can we internally rotate this? Because if we're aiming outward, the target is probably Z plus. It's probably aiming at Z plus. And if it's aiming at Z plus, whatever the field force says, that's where Z plus is going. Now I don't know if it's Y or X. Not this. Not this. Which way does the up vector aim? But which up vector is doing the aiming? I don't know if that's X or Y. I don't. It doesn't matter. We just need to know which one it is. We can switch in between them. So if Z is the direction that the field flow is going to follow, we need it to be flowing along the outside. It's a tricky one, everybody. It's a tricky one. I think we're gonna go over in length again in this episode because we've barely gotten started. I said like 10 things I want to explore, and we are still just on the target to try and get the orientation correct here. I'm trying to if we can figure out the math properly. That's the thing about tutorials. If you can figure it out once and be like, do this step, then the 1,000 steps we took to get there aren't relevant. We can hit 1,000 dead ends, and as long as the final one is correct, then nobody ever has to do the other ones. Like I was saying, we could manually make a series of different hairs and have each one have a different orientation. We don't want to do that. Like that's way too manual. But using a field flow so that they could choose the direction along there, that is way more elegant. That is something people could use. That is the direction. Zach, I'm trying to figure out what you meant by don't use a target effector, use a plane effector with fields. But using fields with a plane effector is just where does it get applied? That's all it is. There's no directional information. The direction comes from what we manually type in. It doesn't come from the rotation itself. There is no transforming based on like the orientation of something else. So the target effector is what's actually giving us the rotation. Super interesting. X. Yeah, the X gets confused when it curves one way. The Y aims upward, but this one gets confused at the top. Yeah, well, it's better to get confused at the top than the bottom. So, I mean, I'm sorry, the side. So the bottom, if we use Y, that gets confused on the bottom and the top. But I feel like that's where you can get a nice ridge if you want to. That's better than getting the weird one on the side. And aiming at Z plus is just going to completely change orientation to be forward. And then it'll get confused, I think, on the very front and the back, which in this case might be the best one to do. Like they're all trying to orient themselves forward. So that's fine. That's where they get confused. I'm wondering, I'm trying to, your fall off or your plane effector comment is making me think, like, can we use this orientation and then just use that to add curvature? No, it's super arbitrary. I mean, you can see here on the wing that these they are orienting towards Z, but they're not aligned in that curvature. Now it's no better with hair, so we're no worse off. I really wish there was a way to make them target not the next node, but like the points of another object. But you see these all rotated like that. And if we were to turn on the plane effector, which we have to reactivate here, then yes, we could grab those and add on some rotations, assuming these are correct. Oh, it comes after. So the plane, we can add in a rotation. Not that one. Not that one, but this one. So these will all spin 90 degrees, and now we get all the advantages of them having their other orientation be facing on Z, and now we can rotate them like that. But you'll still see that we still have the problem of these scales are like up here, they're all still traveling along the line. And then here, they're still not aligned. It's not the worst, but they're not aligned in the way we'd want them to be. Now, then the thought turns into, can we use, like if I were to make another plane effector, and we apply it, and let's just call this one wing rotate. Currently, this should be applying everywhere, right? Yeah, so this is applying everywhere. So let's say we want this part of the wing to look like that. That's supposed to be more in that orientation. So now we would take a spline in that area. So in this case, we can just draw one, I think. I'm doing this as a kind of a proof of concept, but I got to tell you the truth, this is not. All the clones are choking it out. Turn off the clones. Okay, now turn off snapping. Apparently we're snapping. So I want to. Maybe we weren't snapping. So I'm going to draw that. Just sort of follow the curvature of the wing. Escape. Go to a 3D view because I'm certain that this is not aligned. Grab this, pull it back only on X. Grab this, pull it back only on X. In fact, a good idea to look at from the front. And now I can R, rotate, spin that. E. I think I rotated a little too much. Grab this one, move it further in the wing, R, rotate, spin it in. There we go. That should be following that pretty well. This is neat, but it's very specific. It's very limited. So inside of that, we can go into the fall off. Let's return on our clones. Currently, this is making everything rotate. Ooh, and even at like these Z forward ones, you see those aren't perfect either. Or is it series of no? The fall offs take the angle. We can't give a target. Let's use a matrix. A matrix. Oh, that's the variable I might have been forgetting. The matrix. That's how I made the old rig. I'm trying to remember the time I did this kind of layering of things. The rig I made was like 15 years ago. Like when the target effector was new. The matrix object. I'm going to finish this thought and then I might really, if you thought we're down the rabbit hole right now, if you think we're down the rabbit hole right now, it's going to get way deeper. All right, so I'm dropping in the spline into the fall off. What is happening? Why did it turn yellow? Whatever you just did, undo. All right, fall off. Yes, thank you very much. Drop the spline in. What? Undo. Why? Why? Here I've got a plain wing rotate. It's, I say, well, that's it is using the field color. Fine, fair enough. I'm going to go to the fall off tab and I'm going to say, okay, let's even lock it. I'm going to lock that, deselect, grab the spline, drop it in. Doesn't show up, but it's affecting the color. How can it be affecting the color if it's not there? Now, it might just be having a refresh issue. So yeah, if I turn on the color, you can see it suddenly activates. If I turn on that, it should activate. But yeah, that's just a bug. So yeah, it is what it is. Okay, so now it should be affecting the fall off. Fine, cool. It should be based on the radius. The radius can increase. And now you can see as I increase the radius, that it's now making that be the section that rotates. And as I increase this more, it's going to start spinning the stuff around it. We don't want to go too far. So let's go to 150. And then make the inner a little bit stronger. So now you can see that I have spun those 90 degrees so that that has a different orientation than the rest of this. So these are following that, and this is following a 90-degree rotation. Now, we have to keep in mind, first of all, it's still messing up the Z ones in the front, so that doesn't work. And we've very manually applied this. So like we've got this really lumpy transition happening up here. Which, you know, changing the fall off will change that. We can change where the spline is, get a better transition between them. The Z really messes us up. But what I was going to say is the reason that this sort of works is because this is almost perfectly going upward. So we can just say, oh, it's 90-degree rotation. But this one, these are not rotated 90 degrees. They're rotated some arbitrary angle that's slowly changing over time. So that becomes less useful there. All right. How do we test the target matrix concept? That is it even relevant? Because I could use a matrix and pick a rotational target. That's fine. And then I can pick a secondary one, but then that's just going to aim at a new direction. The X of the clone. The X angle of the clone. Man, this is trickier than I thought it would be. This part specifically is trickier than I thought it would be. Now, well, I mean, this is not a huge improvement, but another thought I had was if we steal this spline fall off, copy. No, we need the direction still. X. That becomes a fall off. If the target's, oh man, I am so sad that this, unless that makes the fall off. The fall off has two variables. Is it looking at the direction and is it looking at oh, maybe that is how it works. Oh, instead of making two tabs, they made these two things. Oh, interesting. Okay. So as an improvement on the plane effector idea, instead of using this plane effector, we're going to copy that spline and I'm going to make a second target. And now this is going to be target wing. Target wing 1. This also gets applied. The effector we don't need. That, we don't need that, we don't need. Oh, I guess that one is doing a 90-degree turn. That's fine. No, it's not fine. Turn it off. That's not doing anything right now. So that's dead. That's dead. Target wing 1. Okay. So what do we got? We got a target, the overall target. Now I'm going to target the wing. So now I have very specifically, I want this secondary one, which is just a duplicate of the first. So it's doing the exact same thing. I want it to, right now the orientation is trying to aim all of these. I miss these. Is this even correct? I might need more layers, and it gets too complicated. I don't know this for a fact, but I hope that I have an intuitive sense for how far I can push something in a tutorial before it's like, okay, you've lost me. And I thought I had something that was in kind of one extra step, but now it's like, no, it's a nested step, and it immediately gets too complicated. That may be, Bobby. That may be, but our challenge is to solve it here. So we can get the direction. Currently, it's getting the direction here, and this direction is not good because it breaks here on Z. So instead of going on trying to aim at Z, we could try and aim at X. And now you see that it fixes. Oh, it doesn't fix entirely because those will still be broken. And if we set it to Y, then they become vertical, but they're not broken. So they're facing Y and they're not broken on the wing. And that is still using the surface of the dragon to generate that angle. Now, if I were to, let's see if I still have it copied. If I paste in the spline, this becomes a mask. So now I'm saying, yeah, so you can see that, right now, all right, let's turn that off. So we've got everything's traveling this way. I'm going to create this new one. And now it's saying, no, everything travels this way. So it's completely overriding. But then I can use that as a mask. If I turn that on, then this becomes a mask. So now we have two different target effectors and one has a fall off. That's why I didn't think we had. I thought we had to layer these, but by turning that on, that becomes a mask. So you can see that these all have this nice orientation, and then these all have this nice orientation, traveling upward. Now, the problem there being is that they're traveling straight up on Y. Their Y is their orientation that they want to line up. And that is where we start to get a little bit of a problem. But that's something that gives us an orientation there, and it is still using fields because we're using the field direction. So that's not a bad thing. So you can see how we get that nice rotation there. So now we can apply the transition here is still potentially a little fuzzy, but that goes into, there's no way to control the thickness. The radius is, there's a radius fall off. So, that's kind of cool because that means if we draw a spline here, it's a little chunky, I think. Oh, goodness, we're already on multi-instance and this chugs a little bit on there. I guess it runs fast after it's been calculated, but I don't know which is the start. I started here, so that's going to be a start. So that's here. So if I wanted this to be thinner, I should be able to just grab this and pull it down. Yeah, you can see I can change where the transition happens by changing the radius. So it's nice to be able to have that kind of artistic control. Now, okay, that's fine. Let's say that we also wanted to take other areas that are more vertical than anything. So that would be this leg, for instance. So we just need to draw this along the leg. This is not about doing the direction. It's just about creating a fall off. Hit escape. Good enough. And then inside of our target wing, or I guess this shouldn't be target wing, it should be, the better way of describing it is target Y plus. So anything that's more Y plus than anything. This one is the default, which is where it is more, what is it? Z plus than anything. Target Z plus. So if we continue to layer up, and I'm going to make a duplicate of the spline because that's settings I like. So I will copy, paste, and it gets replaced by new spline. And then we turn everything back on. Then there should also be a fall off here. And you can now see that these are vertical. And so those are both there. We need to add them together so that these two masks can combine. So you can see that's vertical, and now this is vertical. So we can draw a series of lines where things are more vertical than they are horizontal. And based on the fall off the spline, that we can get that transition. Dee Dee, you're too much. Yeah, so these are now more vertical than they're horizontal. Now, the next step, just out of curiosity, would be reactivating our plane effector, which is going to rotate everything 90 degrees. So we turn that on, and everything rotates 90 degrees. So now these are perfectly, hopefully, because we chose the right orientation, these are perfectly horizontal. Yeah, they're pretty cleanly horizontal, although I think we might get a flip there. It's hard to tell. But everything is now spinning. I mean, we only did one leg and one wing, but it's kind of it's a proof of concept. And you can see that this transition is a little bit rough right there. But yeah, then we get that transition. All these are flowing. All right, they're flowing fine. Now, there is additional hope. There's actually more hope for this than I was initially thinking, because I thought we still have to do the hair technique, but I don't think we do. So let's just assume that we've built a flow here that's good. I don't know that we have, but we've got a flow. So these transition, I don't know how rough the transition is, but they transitioned in. That's all fine. The scales aren't very big right now. We're going to be feeding bigger ones, but let's fake it for a moment, at least, by scaling these up a little bit more. So I'll scale these to 6, even 7. Go crazy. All right, so now we got that. So now also on our plane effector, we don't have to rotate. That's the 90 degrees. I'm going to try rotating the 122. Is that the one? Yeah. So by twisting, you see that they're tiling better now. So there's more of they offset, and it should pretty much be across the board. They're tiling everywhere. All right. Yeah. Okay. Let's see what happens. I'm actually more hopeful than I was a minute ago. There's a little bit more of a flow. Now his face definitely has a twist, but we're going to try. Well, okay. Let's just see what happens. So that's all fine. That's that. Now, let's assume that these are going to be generating. We also need something that's going to generate the direction. So is that as simple as creating a copy of that entire cloner? I'm going to hide one. And we need another straight spline. And last time we were using the helix, and they did a good job, so we'll do that again. 0, 0, 0 rotation, a height of, I don't know, let's say 50, and as few points as possible, which is 1. Don't have any subdivisions. Okay, nice. So this goes into our second copy of a cloner. Now, I don't know what kind of rotations we need, so let's just slowly figure this out. I'm going to 0 out its crazy position inside the null. Okay, and now we need to figure out its orientation. It does seem like it's rotated all crazy, but okay, and there is no 90 degrees in here, but this is not a bad thing yet. It's getting the same effects as everything else was. This is fine. So actually what I'm going to do is select, I need a different copy of the plane. So this one is going to be scale rotation, and then this one is going to be flow rotation. So inside this is going to be the cloner for, what is happening? Cloner for the flow. All right. So cloner for the flow. I don't want the position, or I don't want the scaling. I want the flow rotation. So now we can control the flow rotation from this one. If I set that to an even 90 degrees, and then actually let's 0 that out. Where is it aiming at 0? Apparently nowhere. That rotation doesn't mean anything given this one. So let's do a different one. There we go. So 90 degrees is now giving us a flow direction. You can see that because we've figured out the orientations pretty well, this is now an orientation that is giving us the direction it should be aiming in general. Now, do these curve with it? They do curve. They're curving all right. Now, let's push this further. If I increase this, okay, you can see as I do this, it's aiming outward. They become more like hairs. So what we want to do is, what was that, 90 degrees? I want it to not be 90 degrees. I want it to be 45 degrees, because what that's going to do is say, push in that direction, but also inward. Push it in a particular direction, but also backwards or inside. Now, I actually want to flip this around to be the opposite orientation. I want it to be tilted the other way. So that might actually mean we want to go negative 45. Yeah, negative 45, even better. So just once again, for clarity, these are all aiming and they're flowing now back along our entire critter. But if we say 45, it's half that amount. So now it's aiming inward and back. Cool. There's a little bit of funkiness here, which worries me a little bit, but we do have a lot of polygons there. We might need to change the flow. Let's just see what happens. And these seem to be working pretty well. I mean, it's a little bit weird on the tips. We left those sloppy. I wouldn't be surprised if they look a little weird on the feet. Actually, they're doing surprisingly well on the feet. Kind of shocked there. Okay, so that gives us our flow direction. So there's our flow. Now, this was kind of our test. I'm going to leave a duplicate of that just so we can get back to it if we need to. This one is going to be cloner scale. So this is going to control our scales. Well, let's rename it scales. So this is all fine. This is good. This is not rotated. That's not rotated. And that's not rotated. So I don't think these nulls are doing anything. So now we can go back to our Bezier and make a duplicate of the Bezier in there. Turn this off and hang it. Call. Okay. Don't need the hair. Get rid of that. Okay. So we've got scales. I'm going to, let's turn those on. Okay, so what did I turn on? Yeah, here. Is that right? Okay, oh, let's also go to the transform and not scale them all crazy long. Okay, so is our orientation correct on these? It's not necessarily going to be, because we need that to be on Z, and I think we designed them to be on Y. So let's fix that. You can see, yeah, we need the scale is supposed to exist on positive Z. So is there an internal setting? There is no direction here. So I don't know if that's a good idea, but I'm going to just fix it by rotating it. So I'm going to rotate this 90 degrees. I must have made a copy. Yeah, turn that one off. I'm going to rotate it 90 degrees. And then I think we need to subtract 200. No, this is very tiny. So what's the length? It's 24. So let's just zero that out. There, it's at 0. And now what's the height? The tricky part is I can't see the axis it's on. We could do this easily. I just need to see the axis. So I'm going to hold down Alt, make the sphere apparent, set that down to 5. There we go. That's where the center point is. So I can grab all these points and scoot them here. We didn't have to, we could have made this a lot easier. I'm just trying to keep it semi-parametric with our Bezier curve. So that's going to pivot from that spot. So that's all that was doing. I might need to flip it 180 still, but now it's facing along a Z positive. The axis is actually still a little off, but you know what? I'll just scoot that back a hair. I guess we can see it as a dot. That might be a null, but there's a dot there. So let's put it there. Okay. So that's oriented differently now. So if we turn on our scales, now you can see that they are pointing upward and they are twisted. I do have to flip it 180. So I'll turn it off. This is an easy one. We just grab all these points and spin them around 180. We could figure out exactly what that axis is. We're at the step right now where we're just eyeballing things. So I'm going to actually pivot that from where it visually the actual geometry is. Okay, now that we've done that, we turn on our scales. And there we go. Now the scales are all oriented in the exact way that we had built our earlier flow. Based on the target. So these are rotated correctly. The leg is, I mean, correctly is a relative thing, but they're all rotated. Now, a lot of this overlapping, the way the spin is pretty extreme, and we have that in our scale. And we did it with this 120. If we go to 90, you're going to see them line up very nicely. You can see they're all perfectly lined up. So I'm just going to say, sorry, 95. Just a little spin. I'll do 98 just to get that little bit of extra. So now you can see they're tilted just that little bit, so they're not quite overlapping. Some of them might be overlapping, and we might not be able to stop them, but now they are. Now we have a direction, and we are able to sculpt the direction via full on X, full on Y, or full on Z. But at least we can transition between them, which is the transition we're seeing right here and the transition we're seeing right here. So these are not only giving us that direction. Am I still using the surface? Yeah, there is a surface. That's still giving them the direction. I wonder if we need to do that based on the object. That'd be something to go back and check. And I think that this calculation is going to be slowing us down a lot Every time it's trying to refresh, I think that doing calculations based off the surface is really dangerous, and we're doing it twice. So that's a danger. But anyway, let's give it a save. So now, what do we got? Well, we have a series of splines that travel along the dragon. And I'm going to visually hide the dragon. And you can now see like these little splines. We get this whole series of splines traveling along the dragon saying, what direction should this be flowing? So if we feed that into, yesterday we saw that we had to put into a connect. If we put that into a connect, I don't need to weld it. That should be returning, with any luck, a whole bunch of, is it rotated? It's not. So I'm just going to put that as a direct child. That should help. And then is this, I think I'm not sure where we ran into it. I'm going to turn off the scales. We also don't need that older one. Keep simplifying. Okay. So when I put this into this connect, you can see it's making all of our splines disappear, but I'm going to try and turn it on and then try and put that into a spline mask. Does that fix it? Doesn't seem to. Well, what we just need to do is see if the field flow is acknowledging them. So let's just do it one step at a time. Let's pull this out, go into our field force, which isn't doing anything right now. Drop this inside the object. So it's going to take that in as a spline object. And let's see what that gives us. Let's grab that and make sure, very important, make sure that your field force spline has an offset of 100%. And now you can see it's everywhere. And now our resolution here is not high. So in order to see if our curvature is working, you can see that there's some different orientations, but they go out forever. I want to see a better resolution. So in our field flow, we're going to display, and these are just too big. So I'm going to drive 555, 555. Now we get this nice little cross section. I can move it around different spots and we can see what's happening. Now this is just cutting right through. I gotta say, it doesn't, they're all just aiming downward. That doesn't seem right at all. We want it to be along. That is correct. It's a spline object, but all these little helix splines don't seem to be acknowledging correctly. So let's move on. Assuming that's not working correctly, we'll put that into a connect instead, and we'll try feeding that in. So it's now the connect, and these are still there. These didn't visually change, so not great. Now, oh, I just remembered something. Let's simplify again, or not simplify, back to the cloner. These are returning multi-instance. I'm going to set them to be an instance. And it's choking on that a little bit, but there we go. It's different. It's got the full offset. Okay, I clicked it and it forced a refresh. And now look at the direction. These are pointing up, these are pointing in. So we can drag that in directly. It just needed to be not multi-instance. Very important. We run into that often enough. Very often we have to remember to turn off things like multi-instance. That can be dangerous. But okay, now we can see that we're actually getting proper feedback. That is giving us this is a field flow. That's a direction that we should be getting feedback. I'm going to turn off that feedback because we don't need it anymore. These splines, and there's way too many. We should probably have done a high poly clone, or like we didn't need this many, is my point. So, but we do have that many. It might take longer to calculate, but those now exist. They don't have to do anything. If we wanted to speed things up, I can make a duplicate of this, hide that, make this editable. Actually, we can put that now into a connect. Make that editable. And now it creates a spline. Now that doesn't have to do all the calculations for itself. And we'll just replace this with that. But let's just keep in mind that we do have the option to do the parametric version. So I'll just display that again, make sure we're still getting these shapes. We are. All right. Now we can turn our scales back on again. And we can turn on the body of the dragon. So now I think we're finally at the step that we can start seeing if this does anything for us. Now the flow direction should be flowing in the same orientation that the scales are. So this should carry the flow on. So now let's make them dynamic. Why not? if we add a dynamic tag here, rigging or simulation rigid body, I don't remember before if we had set it to a moving mesh or not. Moving mesh is going to be the best that we have. We only have 4 polygons, so we'll do a moving mesh. No bounce, no friction, no collision noise. I think that's all we got to do. Although before we did, I think, add a lot of drag to slow it down. I don't remember if that actually worked or not. So let's just go one step at a time. We don't need to add things we don't know if they're going to help. Okay, so then, okay, we're getting there. Dynamics connector. Now, if we turn off this, we can see our single little Bezier scale. Put this hinge as a child of it, 0 out the Z. There's our hinge. I'm going to spin it 90 degrees so that it's hinging correctly right on that scale. What is this connecting to? It's going to connect to the Bezier. With that connected to the Bezier curve, that should give us a point to pivot, and we don't have a secondary object, so it should just be stuck in space. It's not going to ignore any collisions because it's not colliding with anything. And just for fun, if I pull this out and we have our connector, and I'm going to do an incremental save. If I play, oh, that just flies away. Why is it flying away? Why, I ask you, is that flying away? Maybe we have to make it editable. I know it's a weird object, so it does fly away. Now I'm going to make it editable. And then check out the connector and say, hey, connector, be connected. Now we hit play, and it sticks. So, okay, we might have to make that editable. Not surprising, but too bad. But in any case, we might want to go back to it, so I'll keep an original. Now we make that editable. The connector's already connecting. It's not connected to anything else. So you see that we have a hinging scale. Cool. Now we put that into our cloner scales. And we turn that on. And now we've got a whole bunch of scales that are hopefully minimally intersecting each other. We have well, let's just see. I'm going to turn off this field force for a second, so we don't need to worry about that. And we just saved incremental, so I'm going to just save over that one. Let's go frame forward one. I want to see what happens. See how long it takes you. It's longer, but it's not like crashing long. So if I play, I should be able to pause it. You can see that these are all, they're doing something. Why are they falling? The hinge should stop them from falling. None. Why are they falling? It's acting as if the hinge isn't even there. So I'm not sure what we're missing there. I'm going to look at our old file. And let's see what our setup was. It doesn't look very different. We've got our Bezier. We've got our connector. The connector is set the center of mass. It's directly there. It's a hinge. That's all good. It's in the cloner. I know why. We forgot to turn off multi-instance. Whenever something's happening and all the other explanations seem correct, or they seem like they should fix it, but there's nothing wrong, check your instance mode. Having changed that instance, if we hit frame forward 1, it could take a lot longer to calculate. Yeah, that is a lot longer. It'll go, but it's a lot longer. I'll save it again and hit play. And it felt like it took about 5 seconds for a single refresh. But we got to keep in mind, this isn't for an actual animation. This is just for getting the scales correctly aligned. Now, they're doing their own thing right now. Like there's nothing, I don't have the field force on. So you see they're just randomly moving on the hinge. That's fine. It's running. It's not running as smooth as yesterday, but I think a lot of that is probably because of us using the surface direction. I'd have to try and I want to try and figure a way around that, but let's not worry about it yet. Okay, now we turn on our field force. Turn that on. It's currently up really high. I'm going to put it back down to something reasonable, like 55. And Shane is saying that the wing seems to be flowing backward. Is it? Are these? Those seem all right. I mean, they're intersecting each other a little bit more than I want them to. But let's just see. I'm not sure what you mean by the wing flowing backward. Okay, so let's just hit play and see if the field force does anything. The field force should hopefully be, it's possible it's backwards. So if they all seem to be going the wrong direction, then we have to invert that. But let's let this go and see what the general feel is. There's a lot of intersection in the beginning. They seem confused. They do seem to be, okay, we got to give them more spin, and they do seem to be trying to go in the wrong direction. So the field force spline is coming in backwards, so we just have to set that to not be inverted. And then I think we need to go to our plane scale, and we had rotated it less, but I'm going to increase the rotation again. So these are all spun a little bit more, which should make them less likely to intersect each other. Like up here, they're no longer intersecting, even though they had been down here. And let's see if that helps. Save, play. The feet look a little bit crazy, but let's take this one step at a time. A lot of refreshing here in the beginning. They seem to be following the correct direction this time. All right, not bad. Not bad. Very nice. Now, okay, something I just realized. I didn't add a okay, well, first of all, not bad at all. First of all, let's let this calculate this. It's a lot of clones, so it's going to take a little bit. But you can see that immediately, look how much cooler he's looking. So, immediately we've got a little bit more of a something now that these are rotating correctly, dynamically. Now, I didn't make his body a collider body because I wanted them to be able to, they didn't have to intersect with it, so they can kind of freely flow. And I was thinking that's fine because if one scale collides with the next scale, that will stop it from rotating, and it has to pivot from there, so that would stop it. Over here, his scales weren't big enough, so they're able to miss the next one and just continue passing through. So I think the next setting to play with here is we have to scale the scales based on the scale of the polygon that they're currently on. So let's do that. Rewind. And it's a little, oh man, it's really chug-a-luggin'. And I'm telling you, it's a surface calculations. How do we stop that from happening? Does the target, it's these two targets are doing it. We can't turn them off. We could make the cloner editable, and then they would stop calculating those, but that's a blunt tool to use. Okay, so we are currently on polygons, which means we can enable scaling, and that means the polygons are going to scale based on how big their individual polygons are, which is excellent. So let's see, how big and or small do we want to get? These are getting huge, and then these are getting really small. So let's go 50% of that amount. And is it going positive and negative? Let's see, twirl that down, spline scale. Well, it's nice that we get a spline at least, but does it scale up and down? I feel like these are getting scaled down, and I feel like these are getting scaled up. Let's just see. Yeah, they do. They get smaller and bigger. I guess it's how much do they match their polygon. So yeah, those will get a little smaller, and these will get bigger. And yeah, I'm fine with that. That looks all right. Like the ones on its toes are way tinier, so the smaller scale should help. All right, it's gonna chug-a-lug again, but let's save it and let those do their thing. Hopefully they're all the right scale now where they can collide with each other and they don't need to collide with... I just remember, well, I want to test something actually. We see how long those are taking to calculate. I want to see if they're any faster to calculate if we change this to be not a moving mesh, but a... Actually, let's see what we had set the other one to. We had this one running pretty well. It's not static mesh. It's a automatic. We left it on automatic, so we'll do that. Which might mean it's turning into a convex hull, but we'll do automatic. And that might speed up a little bit, but I still think it's the surface calculations. When I had done a demo, did I ever release that tutorial? No, I haven't released that tutorial yet. I recorded a tutorial, and the T-Rex is like stomping through some particles, and he stomps so hard, or he doesn't stomp so hard. He's stomping, and I was trying to do these surface calculations, and it was taking so long to calculate on the dinosaur that I deleted all the polygons except for a couple on his feet in order to make it work. Once it gets going, it's actually not too bad. It's not perfect everywhere, but let's see what we got. First of all, let's take a look at him. Oh, nice. That's pretty good. It's pretty good, everybody. Let's make him look better. I didn't do this last time, and we should have. Let's make him shiny. So let's add a Beckman with, oh, he's a shiny dragon. Look at him. He's beautiful. So, but we're supposed to have a blue dragon. So let's make him, what am I missing? Fresnel. Fresnel, that's what I'm missing. Dielectric. There. Now he's a little shinier. And do we want to invert this? Does he look better one way or the other? I mean, that's more linear, so I like him kind of being this almost like a velvety color. And then we need an HDR just for fun. So I'll save incremental, and let's create a HDRI studio rig and turn off the floor. And now we can choose, I think he might, well, he should be either outside or he should be with this nice metal. Let's find one that looks nice for him. Let's get him some color. I know it's my go-to. Let's try Botanical Gardens 1. Oh, and let's try Derelict 1, which Derelict 1 is always just amazing. Actually, in this case, Botanical Gardens look better. There we go. So now we've got our shiny dragon with all of his scales so gleaming. Turn on SSAO, get a little shadow in there. And now you can see all the work we were doing was to get all the scales placed properly and get them with the right flow overall. Now, it's not, well, first of all, the flow, a lot of stuff we didn't try and clean up. The only ones we should really pay any attention to are this leg, which we did a pretty good job. That, like, this transition is pretty, I'm really, look at this transition, beautiful into it. His like a couple, like that one's not great, and then let's see what's happening underneath. Well, this, keep in mind the angle we're at is going to be relevant. Oh, and you know what, I didn't even think about it. I didn't turn gravity off, so we still got gravity turned on. So these bottom scales are less, they're going to be flapping a little bit more down. So we should resim. And then these ones in the leg, they're not quite, there's not enough subdivisions going downward. So that's a relevant variable. So let's hit play. Yeah, Dean. Well, I'm glad. That's one of our tricks here. You just got to keep on pushing through until you get it working. And it's a little, it's not more manual than I thought it'd be. It's actually pretty much exactly what I thought it'd be, but with a completely different workflow. I still have some other thoughts on tweaks I want to do on it, but yeah, there we go. And now the belly's gonna be there. And we want to let these settle a little bit. I think in the other one we used a really heavy friction tag. And then another idea would be to use, there's different things we can do to stop these from flapping around so much. But anyway, he's all scaly. And now you get this beautiful transition here. And, you know, it's going to look really good when you're looking at him frontal. But if you look at it from the point, an angle that the scales aren't designed to flow, it might end up looking a little bit weird. Let's see what happened with the wing up here. Now, we didn't do any cleanup along these lines, and that's definitely one of the weirder angles. But this transition is not bad. Like, those start aiming backward in here. So there's definitely something to be said for that is working all right. And then So, but the point being is, at any point we can just be like, cool, done, make it editable, fix the individual ones that aren't quite working, and then you'd be rocking. I can't believe how like a terrible mesh this is, and then you go and you put these scales on it, and suddenly it's like, wow, he looks cool. I mean, still a little cute and cuddly, but that's good. And then we did this the other day. But if we did this yesterday, if we take the material and throw it on the dragon as well, any of the little gaps that you see through them are just going to disappear. So, obviously you wouldn't want it on the mouth and whatnot. In fact, we can just limit this. So there, now the rest of them, it's not there. But now if we were to look at them in the wrong angle, we're seeing underneath the scales here, but you can't tell because it's just blue. So keeping in mind that the only two quick little fixes we did were a little bit of flow on this leg, which is working really nice, and then a little bit of flow on this wing, which is good, and the transition from the body up into the wing, very nice. We've got the overall scale, the scaling based on the polygons actually goes a long way for us not having a very even polygon flow. This one, I think they were intersecting a little bit, so they are fighting each other on some thickness here. We might need to increase the steps per frame for that, or it might just need a little more mesh density to go. Tail's looking great. The leg didn't do anything, but even the feet, I'm surprised at how nice they look overall. So yeah, for anybody who was missed yesterday, I'm sorry that you missed. That it took so long to get to the punchline today, but we already knew this part of it. So, getting this working a little bit better was our goal. Now, just for fun, I mean, once again, this is a complicated rig. Well, I don't even know if that complicated. We did a lot of funky things to get here, but at the end of the day, I don't think it's that complicated. But it's a parametric rig for the most part. I made some things editable, but I don't think we didn't need to make them editable. So we can go and grab our scale clone here. We did this a little bit yesterday, but let's make a fancier version of it. I'm going to add a random effector. And I don't want those changing the position, but I do want it changing the color. And we have a material on there, so we won't see it yet. But if I pull this off, we should see, hopefully. Yeah, so he's got a super crazy color. Under random, if I pull back on his min, we get something like that. And that's already cool, but we can control the color very directly if we wanted to. But he's looking all speckly there. If we go into our blue material, we will instead set this to white and dark gray. And then we could layer, I'm going to fusion, because we only have two. So I'm going to fusion this with a a MoGraph color shader. And it's going to look at the color of the object, and that entire thing, like you can see, that's being applied here, and I can now multiply that on top of it. So now we should get the Fresnel effect. I hope it shows up in the viewport. We should get the Fresnel effect on top of that. But if we throw this into a colorize, is it going to work? Even now it should turn black and white. So not going to go in. Oh, the material's not applied. Wah, wah, wah. Gotta be careful. There, it's black and white. You see it's randomly black and white now. But set this to randomly a light blue. And randomly up to dark blue. Very colorful. Now we get those different scales, and we can even work our way. I mean, that's way too far into the light blue. Pull that down. Whoa there, little doggy. Well, I don't know what just happened. I thought I deleted it. My hand wasn't even on the keyboard, and suddenly the color came back again. But we are letting it chug a little bit. So, but yeah, we could, pull the colors in and say that the dark blue can be darker. And anyway, the point being is you can see that we can colorize it and get whatever variation we want using the random color shader. Like I say, personally, looked a little bit better before we were adding all that randomness. So maybe nice and bright's kind of fun. But I mean, I guess you want to go easy on it, not too much color variation. And even here, this is colorizing, but if we, well, this isn't this. We're not trying to figure out shader. We already know this stuff. This is not new information. So I'm just going to do a bunch of times because that's neat. I just want to show that you could do that. Back to the regular for now. Don't need the random. you very much. All right, so colorful dragon. Got the scales, everything's flowing, the direction's working pretty well. Now, if we're going to continue, there's a couple different thoughts that we had that we can do some tests in isolation. And you know what, to tell you the truth, I don't even know if all the tests I did here are going to completely work. I have to do more testing. But we can't keep the shouldn't the wing flow the other way though? I don't know what you mean. Or you mean the scale should be going upward instead of downward? Possibly, but we could have told it the orientation to flow that direction. Like, so we could have done that. But I have a couple of different tests I want to try. First of all, I'm going to copy these scales into a new scene file. We're going to create something very simple. Let's make a capsule shape. That's a nice simple shape that we don't use too often. It's got some relatively even polygon sizes, so that'll be our object. Bloop. Now we get our scales to the very simple version here. Or spin them a little bit like that. There we go. Set the polygon scaling more so. You gotta go easy, or you have to go heavy on that. Maybe a couple extra caps up there. Bing, bing. Oh, they get real tiny. I just don't want them to intersect, but I guess they're going to do what they're going to do. All right. All right, so we get all this. They'll intersect with each other, so I think we just hit play. Yeah, boom, like, boom, we get them overlapping. The scaling is a little extreme. Bloop. Okay, so now we've got a scaled Bezier. So now what I'm curious about is if we, see. One of the thoughts was, to what degree can we make this dynamic and have the scales be dynamic? And I honestly don't think we can because immediately this connector is what is enabling it to hinge, and it's hinging off of it, but we can't, it doesn't, we can link it to a mesh, we can link it to an object. Well, let me put it this way. I can say I want this to link to the center of mass on here, and we can make our capsule a dynamic object as well. Create a dynamic floor, make that dynamic, and hitting play, this might stay connected. Bonk. Yeah, it does. Now this should be, I don't want them to, no bounce. Even the floor is fine. Now when we fall, they're all falling at the same height and they suddenly slam through. I'm not sure that should be happening. We might need a few more steps per frame. The point here being that, yes, they are currently connected to the floor. I'm sorry, they're currently connected to the object, but only in a connected directly to its axis sort of way. It's not connected. Oh, that's interesting. I think that these, okay, it does eventually fall, but look, yeah, I mean, it's really cool because you can see those bending and they all fall. So they are stuck to it, but they're not stuck to the individual points. And I can't think of any way that we could make them automatically stick to the individual point that they're on. Even something like a spring, I think here we could tell it to stick to a specific point or a point selection, but we'd have to manually set it every single one because a particular polygon point, it's not based on, it's not automatically finding that. We set that manually, so we cannot automatically have this attached to the surface of an object. So what this turns into then is we need to, we'd put it into its final form. So let's just say we're like, yes, perfect, love it, love the scales. We'll even make the capsule blue. So there we go. We got a, pretty bird. Let's make a, let's follow DD's recommendation. This time we'll make it yellow. We'll get a banana color going. Ta-da. Maybe invert that. Yeah, that's a better looking banana. Okay, so we get that. It's like, okay, nice, beautiful. We've got our mesh. looks like some sort of Muppet, which I don't have a problem with. So we're like, cool, that's the final state. That's what it should look like. In fact, you know what? It's so easy to change. Based on this, we can add a few extra vertical segments. Bink, bink. There we go. That should fill this in a little bit more evenly. Yeah, lovely. So that looks great. And we're like, cool, like lock it in. So what I would do at that point is make this editable. I'm not sure if a connect would enable us to do it. Actually, I've run into this problem before. If we're going to make it dynamic, if I put this into a connect, see if I can not weld it, make it editable. Did it remember? This is, I'm gonna see if I frame forward and backward, it does. Okay, cool. It's locked in. So I would copy that mesh and then probably, you know, bring the old one back, turn it off. So we can let's go back if we need. So now we've got this feather mesh, and there's actually this one extra one from the original. Oh, that's this clone. So we can just hide it. So there we go. We got all of this mesh and it's doing its thing. But if we were to take our capsule shape, and you know what? I don't even want to mess that one up, so I'm going to make a duplicate of it as well. We got our capsule very evenly subdivided. I can make that editable. We can make it a soft body, simulation, soft body, and hit play, and it should fall, and it should be squishy, and it's going to squish and then bounce and do all of the things. That's fine. So that's what we want. And now we can take our scales and create a mesh deformer, make it a child, feed it the capsule as its reference, and then go to advanced and set it to surface, possibly surface area, although I've never been able to tell the difference between them, and then say initialize. And now these scales should be forced to do whatever deformations that the capsule is doing. So if we hit play, then those will now move with it, and because it's squishy, these will squish as well. The important part here is that the scales are flexing now. The scales are bending. So these are actually going to squish at the same time, but it's going to follow the mesh. So as this falls and rolls and bends, it's going to follow, but you can see here that like if it's dipping in, those will also dip in. So it's you know, that just is what it is. I can't think of any specific way around that. I mean, there's certain things we could do that would be really messy, which would, yeah, I can't even make them very specific. I mean, actually, I'm actually somewhat impressed that, like, look how these, you know, even these kind of feel like they have that little bit of separation up there based on the way they're bending. They're not. It's just kind of an illusion of it. Look, even these twirl really nicely. I think I've often gotten like a pine cone question. This would be the same way we'd make a pine cone. Not the squishing part, but the way we kind of did these scales or feathers. But you can see how, you know, if we had a character going and bending and deforming, this would go a pretty long way. After that, you'd have to start attaching the scales manually and scaling them to the proper size. I can't think of any way of super automating that process, because if you were to make the cloner editable, then every single one of them is separate. We could clone. So I'm getting a little lost in my thoughts here. I'm going to copy all this into a new scene file. So if we take this original capsule and we take the overall rig of these, what we could do, and I just don't think this would work, but instead of, let's copy that entire thing and turn it off. And now I'm going to put a single polygon in instead. Let's see how well this works, because we're learning. It doesn't have to be big. I'm going to set it to 2x2. And let's put that into this cloner instead. Delete. And now you can see that we've got all of these little individual polygons going. That's fine. And now what the thought would be is if I make a copy and we turn on the scales in the cloner, but I wonder if we could even get the scale. That'd be good. Let me go back a step. We've got this, and it's a copy of the scale. So this is actually, these are scaling. They are being affected by the scale of the object. So that's something. And just so we can, it might be relevant to scale these up. So I'm not going to make it editable yet. So now I will copy and paste these scales. We don't need the connector. We don't need it to be dynamic. But what we do need to do is turn this on. And these are going to clone onto the polygon center, but not of our overall shape. Instead, onto these not scales. These are just a single polygon. So it's going to be the poly cloner. That is what we're cloning onto. And there's no selection. So now you can see that we're cloning these scales. Now they're looking a little weird, but let's see, we're currently transforming them 14 degrees. I guess those other ones are getting the rotation, but why? What's the pivot point here? 3 can't go that. Oh, okay, it is. So they're aimed up, so we want them to flip around. So relatively trivial to spin them around. Now these did not take on. They did not take on their final form. So what's interesting about this is we're getting really nice placement overall, and we're not using any dynamics here. So keep that in mind. So I've now spun these around. We can place them however we want. So there's no dynamics here whatsoever. But the nice part about this is if we take our individual polys here, and I think, yeah, you see the scale is actually carrying through. Not something I was thinking about, but they are carrying through. We can make that editable and then put our mesh deformer on that. And put the capsule in there, although we don't have our soft body capsule. So I'll just add a new soft body. So if we say, hey, that is our mesh, worry about the surface, initialize, that's going to make it invisible. We don't want that. We want to keep it. So now these individual polygons are being stuck to wherever the surface goes, but we can hide those. And then our individual scales are being cloned onto each of those polygons. So now each of them is its own individual scale. So I don't know if this will look any better. It does seem like it lags a frame behind. We can change the order of operations. And my guess here is it would look correct when it's rendering. It just might not look correct in the viewport. So let's see if you can see that when I frame, it falls behind. But if I move my mouse over, it's going to refresh. So that means it will render correctly. It just doesn't look right in the viewport. But now I will hide the mesh just so we can see what our final scales are doing. So you can see when these fall that they are individual scales now that are running on. I didn't cache it. Let me cache that. Bake. So now those are cached. So now you can see that these individual scales are being cloned, and now we do have the ability for them to pivot and rotate because the polygon that they're getting cloned onto is pivoting and rotating a little bit. So you can see how these are layering up, and we might get a little more detail from it, and they're all clones now. So that just pushes it a little bit further. Now I wonder, I wasn't even thinking about it, but could these be dynamic? Because they're just being stuck. No, because those are deforming. So, but these are telling them to clone onto that surface. I don't know. Well, you just got to find out. If I say, hey, you're not baked, clear. Yes, clone. Oh no, that's these down here. This was a duplicate. I'm going to steal that one. Yes, connector. It's not connecting to anything. So I would think that it's just going to say, like, no, stay connected to wherever the polygon is I told you to be on. I just don't know if this will work or not. So they're dynamic. So, also, I guess given that they're dynamic, they shouldn't be all rotated all weird like this. They'd be out in their out position. So let's see what happens. Yeah, they're on their original position. That's too bad. Let's just make sure that I was correct. And so this is these are going, and they should fall. Are they falling? Yeah, see, those are falling, and our dynamic object, this connector doesn't know what to connect to. So it's not connecting to anything, but there's nothing that we could connect to that would make it continue because it's always just the straight up mesh. If we say this cloner is, when we were doing it before, it's just stuck to where they currently are. If now we say that, no, hey, you're connected to that object. It wants the center of mass, a particular point, or a point selection. And that has to be on a per scale basis. There's no system in order to tell it to travel through. So that we can't make it dynamic on dynamic, but we could make it not dynamic and but to be individual. They can be individual but not dynamic. And I'm pretty sure that we could even make it so that we could make them dynamically flop over and then swap it for that single polygon. So they could be in their kind of final position and then individually move. They'll totally pass through each other. But you can see it here, like they're passing through each other. It's just what's going to happen. But it's neat. And like I said, it falls at one frame behind, but it still works. And I don't know. Well, okay, so that's the concept. I guess we just did the quick testing version of that. So now if we go back to the dragon, first of all, I'm curious about, let's do a couple things. First of all, we made this one editable version of the spline, but let's get rid of that and then bring back our live version. And if the live version is in, we just need to go back to our field flow and feed this connector version in. So there, now that should be working. So that means we should be able to make changes. So what I want to do is, as Shane pointed out, the scales here on the wing are traveling the wrong direction. So I want to see if we can easily fix that. So they should be, that arc should be downward. So can we just go to our target Y plus and say, actually, you're supposed to be Y minus. Bink. And there we go. They flipped around. So it's as simple as that. Should the scales aim up or scale down? So we only have 6 orientations that we can work with based on this target effector, workflow that we came up with. But we can, and now I just easily flipped those scales around. All right. So with that in mind, let's once again we only cleaned up that part and that part. So with all of those caveats, let's animate him into his final scale version and then make him editable, and we'll drop him as a soft body and see, because of course that's going to be our stand-in for, we could build him up as a character and a rigged character. But if it was a soft body, it would work with a rigged character. Oh, I didn't even think about it, but that's going to fix the wing, but now his leg is traveling upward, so we inverted both because they're both on the same one, so we probably need one to go up and one to go down. So yeah, we fixed the wing potentially where those fall up, and now we messed up the leg. I guess the big point there was, did it work? And another thing is, it's working. It's not playing back any slower with this not being editable, so we can keep the parametric version working. So as much as I do agree that was flowing the wrong direction, I prefer it being that way, unless we split it up into 2, which I don't want to do right now. So we'll just let those go back. Yeah, that's fine. Let's let it run through. Big bird pine cone. Few frames. What's interesting, well, I guess it's not too surprising. Do you see how it seems to go faster as it goes? And that's because in the first couple frames, there's a lot of intersections. And then as it goes, it's fixing the intersection. So once they stop intersecting, it's not having to do all these extra calculations, and it starts playing a little bit faster. So the more we make sure they're not intersecting initially, the better it would be. Just give it a few extra frames to settle. And if this works like it did last time, which I hope it does, we should be able to take these scales. I'm going to create a connect. Before I put it in, I'm going to turn off weld. That could just take a long time to calculate. Drop that in. Hopefully it doesn't refresh. And now I can just make that editable. Boom. So now we've got a baked down version of the scales. Undo, undo. So now it's all live again. I guess I can keep that. And what do we need? I'm going to paste that mesh back in, grab the mesh of dragon, copy both of them, delete that, open a new file, paste. Now we have the mesh of the dragon and the scales, and now we'll just do the same setup. Scales are going to be mesh deformer based on the dragon. Let's go to the surface, calculate, initialize, and now it's linking all the different points there. This is only 2 different polygon objects. There are a decent number of polygons on the dragon. There's not that many, but there's some. So let's see how long it takes for him to calculate. But I'm gonna add a soft body onto him. I'm not gonna do anything fancy. We'll just put a floor. We'll also make the floor dynamic. And just to be safe, I'm gonna hit 1 frame forward. Another frame forward. There, it is moving. It doesn't take too long. I'm going to make it run extra fast by telling it not to worry about self-collisions. So that should go faster. So we hit play. We're going to need more frames. So now we've got this is our quickie rigged dragon. So we could build joints into it and actually rig it. But now you can see that the scales are actually sticking to him. He's going to be squishing all over the place. But as actually, there's an excellent example there. As he's deforming, you see how these are bending along in an acceptable way with the deformation. And keep in mind that we have those scales now. So if we create a subdivision surface, we set it to 1, 1, put everything inside. Now we get smoothed out scale. So they actually would be able to flex more without us being able to visually tell. And if we wanted to, we could even make a cloth surface. I'll drop this in here, subdivide not by 1, but we will add a little bit of thickness. Yeah, ooh, look at that. Now it gets that little shiny roundness with a little bit of thickness in there. Let's make them thicker. 5. Yeah, if we go too far, they're going to get balloony, but we do 2. And now just, yeah, there's a more of a, it's catching those edge glints a little bit nicer. We also don't want, but there's probably, there's still going to be that frame of lag. But yeah, you can see how that's deforming through. We can make the smaller ones. Now it's been made editable. So once you get your initial flow, once the scales have their initial flow, then I think you can just do this. We got the dragon. Yeah, we have to do a lot more settings and whatnot, but I think that's going to cover today. We're already, we did another 3 hours. The scale question, we'll add a shadow because so we can see him. Yeah, when it hits the ground, he'll have a little bit of contact point. Super basic soft shadow. There we go. As boring as could be. Where's the floor? Really hard to tell. Shadows. Yeah, there's the floor. So let's just send that to the picture viewer. Don't save. But we'll save this file as dragon mesh deformer and render. An alarm. Usually I would have stopped streaming an hour ago. The first frame's taking a while to calculate. That's unusual. Also, this might make the live stream choke now I think about it. Or did I not? What's going on? Did I freeze completely? No, Firefox is going, but Cinema is not responding. I might have just frozen Cinema. But of course I did just save. Let's see if I can close that. Huh, no. Yeah, it seemed to have... I don't know what I just did, but I didn't like something. But we just saved, and we're just doing a little wrap-up thing. So, along those lines, I guess I can say a big thank you to everybody for coming and hanging out. All the extra people who got to see an extra bonus stream by accident. So, lucky for you. Apologies to everyone else. But, yeah, learned a little bit more about it. I'm going to be doing more testing on this because I think this will make for a good tutorial. Once I get all the little details that are needed, then... I need to know more to make a tutorial of this because we're not quite there yet, but it's getting better. We're getting closer. So it's pretty cool. I like it. I did just update the credits. I think the computer is starting to get affected by whatever Cinema's doing. So I'm going to kill it. Dead. I did update the credits because a bunch of people were very kind and started supporting on Patreon yesterday after the stream. So thank you very much, Dean and Rob. I know for a fact that the 2 of you were the ones who signed up for it. I'm going to continue tinkering with this, and there will be a tutorial hopefully. And who knows, maybe if next week, if things are still going well, or if we need to do more testing, we might continue on this in next week's bonus stream. Otherwise, it'll probably be XP Dynamics. That should cover everything here. Thank you so much, everybody, for the extra questions and whatnot. Anybody who might have randomly come in, feel free to follow us on Slack. So there's a Slack channel for Rocket Lasso. So head over to rocketlassoslack.com and you can join the Slack channel for free. And if you like this stream and you want to support the kind of stuff I do, then head on over to Rocket Lasso's Patreon and follow me there to get some extra bonus stuff, including these scene files. So that should wrap this one up. Thank you so much, everybody. And I'll see you next week. And here are the brand new credits for everybody who started supporting. Bye-bye. because I it did it wrong because when I clicked the ad, it remembered where I played from. I turned that setting off, so now it'll work. Bye bye.